Let's build a full stack web application in Python. That means the front end and back end are going to be written in Python. We won't need to write any other programming language to make all this happen. Now, the final project itself is going to look like this. This is a podcast discovery app, which yes, you can play podcast episodes. You can look at ones that are popular, and then you'll also be able to log in and sign up with your own users. You can see pages and stuff like that that you might end up using as well. Now, all of this is written in Python through Reflex. Reflex is the framework that allows you to write front-end code in Python and back-end code in Python. Now, what it compiles down to is a little bit different than just purely Python. Part of it is using Fast API, part of it is using something called Next.js. But the idea here is Reflex itself, all we have to worry about writing is Python, and it helps us with the design as well. So not just this, but also dashboards too, with theming and all sorts of stuff like that. Now, in order for this to work correctly and have actual users, we are also going to be using Clerk. So Clerk is the partner of ours in this video, so thanks Clerk. But the idea here is Clerk itself will handle all of our user management. So we don't have to think about it at all. And you could do so with like 10,000 users for free. It's incredible. Now, the way it's integrated is with this fantastic open source package. And then also we're going to be using the iTunes search API. So actually searching for podcasts will be free. We'll also be looking at how to use SQL model, which is how you can interact with a database itself, a Postgres database in our case. That's what we're going to be doing in this one. Let's take a look at a little demo as to what we're going to be building specifically. Here's the project we're going to be building. All of the code is available on my GitHub at cfe.sh/github. Just search for the podcast platform with Reflex and Clerk. You will be able to find it. Now, the other part about this is it's linked in the description, but the idea behind this project is to have some sort of way to interact with actual podcast episodes. So the search is going to be done through the iTunes search API, which is actually a free API you don't even need to sign up for. You can just do searches for things that you might be interested in. So in this case, if I were to do a search, let's say for instance for Python, I can search all of the different podcast episodes that are somewhat recent that mention Python. There's a way to search in the description as well as in the title and languages and all of that. There's all sorts of optimizations and customizations you can do for the actual search itself. That's not really the point here. The point here is you can build this out. But what you'll notice is you can actually hit this like button. As it stands right now, this like button doesn't do anything because, well, my user is not logged in. So you can also log in with your user, which of course is powered by Clerk. More on that in a moment. You can use social authentication. In this case, I'm using Google to log in, and then it will log into my user's account, in which case I can actually select various things in here based off of all of that. So I can like different things, I can play it, I can see and discover the things that I have liked, or maybe unlike the discovery page and then go back into my favorites and I see that these things are unliked as well. I can also go ahead and enter some information and send that message, and I can see that data coming back is for a very specific user. This user, of course, can be managed inside of Clerk directly. So if you go to clerk.com, log in to your dashboard, you can search for your different users. In this case, this is that user right here, and I'd be able to manage that user directly in here. I can remove this user, in which case this user would no longer be on my project. So if I were to delete this user right here, I come back into my project here, that user is no longer in there. Yeah, some of the caching is still there, something that I could clean up, but the idea is I would need to re-sign up. I would need to create a brand new user account to be able to log in to this service, in which case you are seeing right now. It's logging in all of the things for this user, and then you would see there are no favorites in here at this point. There is discovery things, so that user data does still exist in the backend somewhere. It's just not for this particular user any longer. But now you'd be able to like things like that. You'd be able to see them. This is all stored in the database as well. And then you would always be able to go ahead and like go to the contact page and quite literally write out some new contact stuff like some other gibberish and hit send, and that's a completely different user. So as far as the code is concerned, what we focus on here is how to actually write Reflex code, which is a little bit different than what you might be used to in the sense that you have something called a state and then you have pages. These things kind of intermix with a front end and back end, and it's all written in Python. So you can do logic like this in Python, but then you can also do logic like this, where it's a condition that's based off of some front end state. In this case, whether or not the user is actually logged in or signed in to their Clerk account, in which case it would actually change everything about what's going on with this application. And granted, we go into a lot more detail and all sorts of other things, which of course is why I recommend that you take a look at the course itself. Now, to me, one of the big benefits of this is having the ability to have some sort of dashboard. This dashboard itself is written in Python, so you can build out all sorts of really cool things in Python if you wanted to. So like, for example, in the actual data tables that we've looked at, what you could do is you could actually take a look at what Reflex has. If I just do a quick search for NumPy or maybe pandas, I can see that there's even stuff for PyPlot already built in. So you can render out things like this inside of your project without a whole lot of extra work that you might need to do otherwise. This right here is one of the things that might convince you to do Reflex altogether, is because plotting out things like this is often very complicated if you're trying to do it as a web framework itself. Also, playing media, being able to download media, all of those sorts of things is just seamless inside of Reflex. And then being able to actually use users is a huge unlock. And one of the reasons why I think now going to Reflex is even better is because now you don't have to manage users whatsoever for a large number of them. So with all that in mind, let's go ahead and jump into this course. Let's open up our code editor and start our project by creating a Python virtual environment. I'm going to be using Cursor, but you can use pretty much any code editor that's out there, VS Code, Windsurf, whatever you'd like. So the idea, of course, is we're going to go ahead and open a folder here, and we're going to navigate to where we want to store this project. In this case, I'm going to call this my podcast discovery, and I'll go ahead and open it right in there. Now, a big part of the reason I used a dash in there was for later, so we'll see that soon. I'm going to go ahead and not use any of the AI tools in this one. Feel free to use them as you see fit. Right out of the gates, I'm going to go ahead and save this workspace as podcast discovery, just like that. Now, most of the time, whenever I start a new project, I also just go ahead and do git init, as in start tracking the code as soon as possible, especially if you're going to be using the AI generation and chat stuff. Make sure you're using version control as much as possible. Now let's go ahead and create a Python virtual environment. And again, I'm using Python 3.13. The version of 3.13 doesn't matter so much. Like I've got 0.2, even though 0.5 is out. Feel free to get the newest one if you'd like. Now I'm going to go ahead and use Python 3-m, venv, venv. This is how I'm going to create a virtual environment. This is how I isolate this Python project from every other one on my system. And I recommend you do the same, even if you're going into production. Now, there is another one called UV. I really like UV. I really like Poetry. Both of them are great. I just have a lot of really good, consistent experience with Python 3-m, venv, the built-in one. That's why I use it all the time in my videos. But in production, I often use other ones. So we'll go ahead and do source venv bin/activate. And just to activate this virtual environment, just to verify that, again, I can now type out Python without the version number, and I can actually get the same version in there. And I can also do something like pip freeze to see that there's nothing installed. Pip, of course, is the Python package manager. We're going to go ahead and do pip install pip and do --upgrade just to make sure that that's upgraded to the latest version. So then I'll go ahead and do pip install Reflex because, of course, we're going to be using Reflex really soon. So the idea, of course, is to make sure that you have all of the requirements installed and running. If you've never done this before, I'm not sure if this course is the best place to start, although you can use AI to fill in the gaps as you see fit. Now what I'm going to do is just bring in requirements.txt and just go ahead and say Reflex for the moment. I might need to change this in a little bit, but for now I'll just leave it as is. Let's go ahead and initialize our very first Reflex project. We're going to be using the blank template or mostly blank template to get started, but there's a lot of them. So be sure to check out the docs for those. So what we want to verify here is that Reflex is installed. So the command line is there. And this should have came in when you did pip install Reflex itself. that will install that command line item on there. Of course, if that's not working on your machine, definitely take a look at the Reflex docs themselves, which I believe is our reflex.dev. So the idea now is I want to go ahead and do Reflex init. If I hit enter, it's going to start this process of building out my Reflex project. Now, do keep in mind, the project name itself is going to be named off of the folder it resides in, the folder of podcast-discovery in my case. Then I'm going to go ahead and use this blank Reflex template. This init process has changed over some time. So I like starting with the blank one. You can use any of the ones that you'd like. I would imagine this is going to continue to evolve, but Reflex init, I believe, will always be the same. And of course, these warnings, we can just ignore those for now. So as soon as I ran this, it updated my requirements.txt to include the specific version of Reflex. I recommend that you let that stay that way. So I'm going to go ahead and get rid of the one that I wrote in there initially and just leave the one that they have or Reflex init gives us. So one of the things that I also am noticing that I really like is it already gave me a git ignore file. This, of course, is for our git version control, which in that last part I did git init really quickly, sort of glossed over that, but git is really important on using going forward. I'm not really going to show git, but I do like that git ignores in there. We also have rxconfig. Notice that we've got an app name in here, which is this one right here. I think the Tailwind stuff might change in the near future, so I'm going to kind of ignore that for now. But the idea is our actual project, all of our Reflex code is inside of this podcast discovery under podcast_discovery.py. In other words, the actual Reflex app is named the same as your holding folder, your container folder, except it no longer has dashes, it just has underscores to make it Python-like. And here is all of the code we need so far to be able to run Reflex run. This will run our application for us. So it does two things. It compiles the front-end application and it runs the back-end application. So if you're not aware, Reflex itself has a front-end user interface that's a lot like Next.js, and then it has a back-end Python interface that is like FastAPI. In fact, I think it's both based in those tools, but for us, all we really need to worry about is what's inside of this directory. Reflex will handle everything else. And so the idea, of course, is if we open up that terminal again, we can now see the backend and the front end are running in these two places. So the app in general, when you're going to interact with it, you're going to go to localhost 3000. Yes, these things can absolutely be configured as you need. You can always go to reflex.dev to find out all of that information under the documentation for the framework itself. And of course, that's what we're going to be building off of. But the idea here is you want to make sure this hello world works. Now, one thing that might cause it from not working is not having Node.js installed. So be sure to download and install Node.js on your machine. This will handle a lot of the front end stuff that Reflex uses, but all you need to do is install it. This is another common thing to install along Python if you're doing any sort of web development whatsoever. Both of these things are used in tandem all the time, regardless of whether or not you use Python or Node very much at all. In our case, we're going to be doing Python, but underlying the actual code itself might need Node.js. So much of building web applications is about responding to events that a user might do, whether that's submitting a form, clicking on a button, or just navigating in the site altogether. We want to see how these events can be handled in Reflex. And if you've built applications before, especially web applications that have a dynamic front end and a back end of some kind, you will, I think, come to appreciate how the Reflex state ends up working. I know I did. So the idea here is I want to toggle the heading. I want to change this title here. I'm going to go ahead and put it into my state. I want to declare the data type, which is going to be a string. I'll set the default equal to welcome to Reflex. So right out of the gates, I can actually change this rx.heading to being state.title. So the important part here is this is a class that inherits from rx.state. So this state class needs to inherit for that in order for this to work correctly. So the next step would be, how do we actually toggle or change that title? So the way I'm going to do this is say new title, and this is going to be a string, and I'll set it equal to welcome to podcast discovery. Something like that. Now I want those to change. So the way we do this is by using a method. We could do something like handle click event, which takes in self, and then all we would really do here is say self.title equals to self.new title. That's it. So very straightforward Python stuff in terms of classes. The only thing I need to add to this function to make it actually work with Reflex would be doing a decorator rx.event. So it's now an event handler. So if you're familiar with building stuff in the front end with like JavaScript in the browser API, what you would end up seeing is something called an event handler. I can use this now anywhere in my Reflex application. So let's take a look. Inside of my heading, let's say I want to toggle in there. I can go ahead and do an on-click event in here, and all I need to do is say something like state.handle click event, right? I can also do it in the text right here, and I can actually go ahead and say on, let's go ahead and do mouse over. We're going to go ahead and do state handle click event. Now, to best understand that those events are happening, I could just go ahead and print out something happened, right? So go ahead and save this, and now I'm going to go ahead and run this application. Let's go in the root of our project here at rxconfig.py and just run reflex run, hit enter, and then go ahead and open up your web browser, which should show us the actual title there. If I scroll over here, right away it changes. If I were to click on here, it should change as well. And of course, it says something happened, so I'm clicking a bunch and it's saying that same thing. So let me just kind of make this a little bit better by also having something like an original title so I can actually see these things change. So I'm going to come in here and do that. Now I'll go ahead and say if self.title equals to self.og title, or rather equals, then we will go ahead and do that new title swap. Otherwise, we will go ahead and say self.title equals to self.og title. So quite literally a toggle now. So now I would call this something more like toggle title. It's now a new name, so inside of my click events, I need to change it to what that new name would be, of course. And so there we go. We now have this toggle title in here. Now, if I were to go over this, notice that when I'm over this, it does change, and it'll change back and forth and back and forth. There's all sorts of stuff going on. And if I click here, it will also be going back and forth. And so this is how Reflex handles that front end state with that back end state. And why is it that we know it's back end state? It has to do with this print statement right here. If we actually open up the terminal, we see that a bunch of things are being printed out in the terminal itself. It is not being printed out in the browser's console or console logged. It's not in there at all. There is a way to log things in the console, but the idea here is this is happening inside of Python, which would be in the backend, which I think is pretty great on how these things are really tightly connected. So let's take this a little bit further, and we'll go ahead and say click count, and I'll put an integer in here, and we'll start it at 0. So in this toggle here, I'm now going to go ahead and do self.clickCount plus equals to 1. So I'm incrementing it every time we do this toggle. At this point, I actually want the toggle to be based off of a button. So I'll go ahead and get rid of this on-click event on the title. I'll go ahead and get rid of the on mouse over on the rx.text. Right underneath rx.text, inside of this rx.vstack, I'm going to go ahead and do rx.button, and I'll go ahead and say click me and put a comma at the end. Again, we want to tie that event in, so I'm going to go ahead and do comma on underscore. Now I can see all of the different events that are in there by default that you can handle by default. These, of course, are all built into the web browser as well. So I'm going to go ahead and do the on-click event now and state toggle title. And I might as well also have the count that's going on. So I'm going to go ahead and put the count in this rx text. I'll go ahead and just say count like that. I'm going to get rid of the code here and just do, we'll say state.count. We save that. We refresh into our page here. Let's go ahead and make sure everything is compiled up. We might have an issue here. Oh, it's click count, not count. Let's try that again. And now it compiles. Notice it said it had no attribute. Count, it didn't. Okay, so here we go. So now we've got click me, and notice it's toggling back and forth, and it's counting that. So we now have a like button, basically. Let's see what I mean by that. Let's go ahead and change the title to simply like, and then the OG title being like. and then the new title being liked. Now, if we refresh in here, I click that button, hey, you like it now. You unclick it, you don't like it anymore. You click it, you like it, and so on, right? So this mechanism is seen in so many different places. Making this happen with basically any other tool, let's say, for instance, Next.js, is not as straightforward as this with including the backend part. React can do this really well, which is what Next.js is built into. But having the backend, you then need to make some sort of API call or some sort of WebSocket call that's just not this straightforward. This is the magic of using Reflex and the state element. We're going to see this a lot more. We're going to build on top of this and make it quite a bit more complex than this. But this alone, I think, opens up a huge world of possibility when it comes to building out your applications. Let's go ahead and add a new page to our project. So in Podcast Discovery here, we're going to copy the index page here, and right underneath it, I'll go ahead and paste in here, and I'll just call this Contact. And then we'll call it Contact Page. And then inside of the app add page, I'll go ahead and copy and paste it, and we'll go ahead and put our contact page in here. Now, I like to be explicit and say what route it's going to be at. In my case, we'll just go ahead and say contact. And so what we want to do then is run our project. So Reflex run, and then we'll jump into that project and take a look at that page. So we come in here, it should load up in just a moment, and then we can go into contact. And in which case it shows us the same thing. So let's change it a little bit by changing the title to simply contact. And we can get rid of the other state elements in here. In fact, I'll get rid of basically everything with the exception of the heading and these properties right here, these arguments to VStack. So I'll leave those in. And so now if we go into contact, it doesn't say contact correctly, but it's getting there, right? So we now have contact in here, like contact us. If we go home, we will see what that home page looks like. So what this allows me to do is I can actually add in different components as I see fit. But what I can also do is I can now link to this page. So in this link here, I've got check out our docs. If I change this to like contact us and then get rid of the href being this whole thing, instead I can use this /contact in here. So we come in here and just do /contact, external being false, save that. Now I've got a link to my contact page. I click on that and it now works. It's not the only way to do it, but it is a nice way to do it. So with those same links, I can go ahead and copy the same thing, the same idea in here, go into my contact page above all these properties or these keyword arguments here, paste it in there, and now I can go ahead and say home and just change that to the home page, which of course is the index page, which of course we didn't ever actually route, but you definitely can by something like that. And so now I can actually navigate between these two pages. So not only do we have pages, but we also have the early foundations of like a navigation bar of some kind. But really the point here though is I probably don't want to put all of my pages on this single Python module. I probably want to start decoupling things, in which case, let's take a look at what that looks like. When you start building out your Reflex application, you're probably going to have a lot more pages than we have here. But I will have some static pages that I'll use probably in a lot of my projects. So those static pages I typically put in a folder called pages. I turn it into a Python module by using the init file. So 2 underscores or a dunder, init dunder py. And then inside of here, I'll go ahead and add in my static pages. So I'll go ahead and do contact.py, and then I'll go ahead and bring in that contact page function. So I'll go ahead and cut this out and we'll paste it in here. And then I'll go ahead and do my import reflex as rx. So really, I just want to check that there's no issues in here. I may or may not want that logo, so I'm going to go ahead and get rid of that and just leave this pretty bare bones at this point. Then I'm going to go ahead and import this into my init file. So from .contact, import the contact page, and then we'll go ahead and export it basically with the all method, which is a dunder, all dunder, and then we bring in the contact function itself. So that then inside of my podcast discovery, I can come in here and just go ahead and say from podcast discovery.pages, I can now import the various pages I might want to use in here just like that. Now, one of the things I don't like about this is then eventually I might have just like a ton of pages in here, right? And which is probably fine for some of you. For some of you, it might not be. For me, I don't actually want to have all of those pages. So I'm going to change my routing just slightly. I'll keep that import in here, but this time I'll just go ahead and say star hashtag no QA, so there's no issues from the web browser. Basically, I'm importing pages to use them. Okay, I'll show you what this means in just a second. But going back into contact now, I can actually use rx.page, and now I can just set the route, whatever I want, right in here. So we go ahead and do contact right next to this. So this is what I'll use throughout. And this import allows for that to work. So if I come back into my project here, let's just make sure that it is running. I come back in, I see context in there. If I were to get rid of this import right here, let's go ahead and comment it out for a moment, save it, it will recompile, and now this page may or may not work depending on how things are remembering stuff. So in these dot files, I'll go ahead and get rid of them or the dot folders rather, to clear out the Reflex cache here a little bit, and then I'll run it again, in which case it'll just rebuild everything, and we should probably not see this contact page being a functional page just yet because of that import, right? So it had some caching with that import in here, but now it's saying 404 not found. And of course, if I get rid of that comment and save it again, it should now bring back that page because now it's actually aware of it. That's pretty much it. Reflex is now aware of it. This is something that you'll see in other kinds of nested applications as well, like Fast API, like Flask, like things that use SQL model and all that. This is just a way to ensure that the Reflex app knows about this decorator itself. And of course, when we imported it, it knew about the function altogether, but now it knows about those decorators too, because there's no like auto discover, if you will, if it's not being imported into the main application. Reflex gives us the ability to be very consistent across many different user interface elements in our project. Let's take a look at that now with creating our own custom heading here. So the idea is inside this heading, let's say for instance, we wanted to change the color scheme, which of course, if we're using some sort of text editor, it'll show us the options in here that we've got. I'm just gonna go with indigo, okay? So I've got this heading and I want all of my pages to have the exact same heading. For example, let's go ahead and run Reflex run right now so we can see what this heading looks like and the logic behind it. Granted, all of the documentation has stuff about heading, color, size, weight, all of that sort of stuff. Let's go ahead and jump into the project itself though and take a look at the contact page. There's this new color, right? Maybe I want to use this color all the time, maybe not. The point here is I want to make sure that I'm consistent no matter what. So if I created a new page, let's say for instance about.py, and we bring in about, and we call this about page, and we change the heading to about, then in my init method, I want to make sure I bring those in as well. So from .about, we'll bring in the about page, and we'll go ahead and add it in here as well, just like we did with contact. Okay, so we now have an about page with the same sort of heading as our contact page. If we navigate to each one manually, we'll go ahead and see what I mean by this, okay? So there we go, we've got our colors going there. I'm just toggling back and forth or navigating back and forth. So I want to make that a reusable element at this point. So that means that inside of my project here, I'm going to create a new folder called UI. Inside of that folder, I'll go ahead and add an init method and also a copy of it so that I can go ahead and create something like headings.py. All I want to do here is make it specific about my page headings. In other words, this right here. I'm going to go ahead and copy this, go into my headings here. We're going to define a function called page headings or page heading, and then we're going to go ahead and return back that element itself. So we're going to go ahead and we'll say our import reflex as Rx, and then this is going to return back rx.component, which of course is the heading component itself, and it has basically all the attributes we want about it. The one thing this function doesn't have currently is the ability to change the title, in which case I'll go ahead and change it to being simply a title like that. I'm actually not going to call it about, I'll just go ahead and call it page, and in which case I'll go ahead and bring in the page title just like that. Great, so now that I've got this, once again in my init method, I'm going to go ahead and do from.headings. We're going to import that value here, and so I'm going to go ahead and grab it as page heading, and then we'll go ahead and do our all method in here again, and we'll see page heading like that. Okay, so why did I do this? Well, it goes back into our About page here. We're going to then go ahead and bring in from Podcast Discovery, we're going to import UI, or this entire module here. And now I can go ahead and say, instead of rx.heading, I can just do UI.pageHeading and then About. Okay, and now I can get rid of this one, and then we'll do this same idea with a comma at the end on the About page. Same idea, same import, all of that. There we go. So now we go into About and Contact. Hey, they are the same. But the big difference here is, what if I wanted to change the color to cyan, for example? Now I'm going to go back into my UI element here, into those headings. Now we're going to go ahead and say it's cyan. And now we'll go ahead and take a look. And there we go. So we got About, and going into Contact, I might need to, I need to change the actual thing from saying About to Contact Us. There we go. Contact Us and About. And the color changed where I wanted it to. Great. So of course I can also change the size as well. But this is now that default heading for the pages. I can do this in other headings as well. But naturally, the next step might be, what about the actual links? Or, and better yet, what about the entire component that's rendering this page? That would probably be even better. But what we've got here is a way to do very specific small elements that can have a big impact across our entire project. And of course, we could also do something like our theme scheme or something like that, in which case we would have it more of a general setting that you could then change as well and work off of some sort of constant. So in the case of like color or size, it's not always that you'll need to create these kind of components. That's not really the point. The point is that we can abstract away some of the components that are already in here and put them into our own sort of components that we can then reuse and make it very consistent throughout. Let's now expand this user interface element to a layout component so that our About page or our static pages basically have the same sort of look across the board. So inside of my pages here, what I'm going to do is I'm going to create layout.py, and I'm going to go ahead and do basically everything from about.py. I'll bring it on in. And in this case, it's not going to be a page. It's just going to be our layout, or let's call this our page layout. And what is it that I want to bring in here? Well, first off, I'm probably going to bring in a child element or children, and this is going to be an rx.component. Then I'm going to add in some properties or props. And the property in here, I'm going to go ahead and say the title, and this is going to be equal to a string, in which case it would be something like page title. In this case, though, I'm actually going to go ahead and say none. So if there is no title, then we're not going to actually display a title. So of course, what is this children element and how I'm going to go about using this? Well, the children element is going to be basically anything else inside of this project or this actual rx.vstack. So what I'm going to do here is do something called rx.box, and then inside of that box, I'll go ahead and put in the children element in here. Okay, so now how do we actually use this page layout now? Inside of About, I'm going to go ahead and comment these ones out now, and I'll go ahead and do from dot layout import the page layout. I might not be able to use the dot notation, in which case I would just go ahead and do the podcast discovery.pages.layout, then returning back the page layout as I see fit. So what I want here is the page layout at like maybe something along the lines of rx.text and say, this is my about page. I'll add to it later. Then underneath that, I would say something like title equals to about page. Save that. Let's take a look at our about page now. There it is. Okay. Same concept. Let's go ahead and bring it on over into our contact page. I'll get rid of these comments here and let's bring it into contact. Same idea. I probably don't need any of that. I'll go ahead and copy this one right here and do that same thing. And there we go. So we now have our page layout. and in which case this is now our contact page. Or let's say, for instance, I forget my title altogether. I'll save that, and then we'll refresh in here, and then I'll go into contact. Okay, and so now it's showing me about. Not sure why it's showing about. Maybe it's something with caching, but it actually has something to do with this right here, and in which case we need to bring in our title. There we go. And so now we've got our about page and our contact page. So we still have the same sort of consistency on those two pages. And in fact, we might want to use this page layout everywhere, or maybe not. Maybe this is just for those static pages. In this case, I'm going to say this is just for those static pages. That's why I have layout.py right here next to those pages. If I wanted to have a global layout, I might do that somewhere else. Or if I want to have other component layouts, I would probably do this somewhere else as well. But the idea here is now that I've got this, I can actually bring in the components and make some navigation in here. So I can go ahead and say contact, and this is going to be contact, and this is going to be about, and this is going to be about, right? I now have the ability to add these things. So now if I were to navigate between those two, it will show that. My home page might be a little bit different, but that's okay as well. There's a lot of different ways on how we can improve the various navigation links, which you might have some sort of sense of right now. Now the contact page, of course, didn't actually have a page title, so I'm going to go ahead and bring that one back. But the idea, of course, is now we have a reusable layout that we can change as we see fit. And it's showing us a little bit more about how these components end up working by customizing and making our own. So all of the other components that come directly from Reflex have their own properties and their own child elements. So all of them you can take a look at. So if you did a search for rx.box, you would be able to see the box component itself, which is a standardized layout item in here, which allows you to have various elements to it. You can pass in a string or an actual component like we did. You can pass in a border color, background radius, all sorts of things in here, in which case we could do that as well. So if we came in here and added those same things into that box, we can come back into our project. There, now it's highlighted, right? It's not quite what we would actually want in terms of the content for any one of these pages, but it is showing us at least what you can do with one of those box elements, and it now applies to all of these different items, of course. So this is my contact page. We want to change that as well. Cool. Let's go ahead and create a very simple contact form. So inside of our app, I'm going to go ahead and create a new module called contact. Inside of this module, I'll go ahead and do an init file. And inside of here, I'll go ahead and do forms.py or form.py. Either one. I like doing it plural in the case of forms because I might have more than one. I'm going to go ahead and import Reflex. So we'll go ahead and do import Reflex as Rx. We'll go ahead and create a contact form state, which is going to be rx.state. And then it's going to take in our form data, which is a dictionary value, which is going to be empty by default. Then we'll go ahead and do an rx.event. And this is going to be something like handle form submit, which will be self, and form data, which is going to be a dictionary itself. So this is the input form data, in which case we can go ahead and say self.form data equals to that, and we'll go ahead and print out what that ends up being. Okay, so there's our state now. Next up, we're going to go ahead and define the form input, or let's call this our contact form itself. And what we want to return here is rx.vstack. Vstack just means that all elements go on top of each other. That's pretty much it. And what I mean by all elements is, of course, rx.form is going to be stacked on top of anything that would come after it. Maybe, for example, rx.divider and then rx.heading. Let's go ahead and say input value, and then we'll go ahead and do rx.text, and this is going to be our contact form state dot form data, this value right here. And we can do something that's to string. So there's a pretty cool element that allows you to take a dictionary and turn it to a string within Reflex itself. Okay, so let's go ahead and make sure we put commas here, and we'll see what this looks like in just a moment. So how do we create the form? Well, you need an input. So we'll go ahead and do rx.input. And you want to give it a name and you want to give it a type by default. So the input name is going to be the key name. The type is going to be what gets rendered on the value. So for example, if I called this your first name, that means that at some point the form data will have a key called your first name with a value from the user input, right? When it's called submit. So that's kind of the idea behind the name element itself. Type is going to be either text, email, you could even have password. There's a lot of types in here. These are going to be an HTML element input type. So if you know what a form input is on HTML, it's basically that. That's true for the name as well. It's also an HTML element because these all get rendered out as HTML. So at the baseline level, I'm going to have the input here. I'm also going to have a button. Once again, this time I'm going to go ahead and say something like send message. And I'll go ahead and give it a type as well, which you can do on a button, which in this case is going to be submit. This renders out to being button, send message, button, and in here you would say type equals to submit. That's the HTML that comes back from that form. Okay, so you want to make sure you put commas in between here. So now we've got our form. All we would really need to do is add an event handler, which is going to be on submit. Then you can call that state. Hey, what do you know? This hopefully looks pretty familiar to what we've done before. And there we go. So we now have a contact form of some kind. So this contact form I want to bring into my page. Now I already have the contact page inside of Pages here. I don't want that anymore. I actually want it inside of my contact module now. So I'll go ahead and do page.py, paste in here. This is going to be my new contact page. The reason for this is because I'm now expanding what this contact page can do with very explicit other things for contact. This contact form I'm probably not going to use anywhere else, but if I did, I could. But this page itself is correlated to that form, and in which case it's no longer that static of a page, so I'm going to remove it from those static pages altogether. Now that I've got that, I need to update my inputs a little bit. So inside of contact here, I'm going to go ahead and put my contact page like that. Okay, and this is no longer from.contact, but rather from.page. There we go. And here I'll go ahead and get rid of the old one. There we go. And so now inside of my page, I'm going to go ahead and do from.forms. We're going to import our contact form in here, and I want to render this thing out. I'm going to go ahead and put it right there, and we'll save it for just a moment. Then in my podcast discovery, I'm going to go ahead and copy the pages one and now import everything from contact. Great. So at some point, my contact page, I might also have a database model. So we would have models.py in here as well. Even more reason to make it its own module because of how we're going to end up storing data and whatnot. Great. So now we've got our contact page in here and our form. We have a problem with our contact page though, and that's how we're using page layout. If you go back into page layout, it takes two arguments, children and title. So we've got a little bit of a problem is because I actually have three arguments in here. So all I need to do is rx.box or even vstack, and then put those two elements inside of there to make sure that I can use that page layout correctly. So now we're going to save that, and then we're going to go ahead and take a look, make sure it's running. So we'll go ahead and do our reflex run. If it doesn't compile, there's probably something wrong with this module itself. It looks like it's compiling. Let me jump into my project here, into contact, and there we go. So we've got all this other stuff. I'm going to put in some gibberish here, hit send message. There's that data. Pretty cool. Now, of course, the data actually stayed on my submit button, right? So what we can also do is after this, we can do reset on submit being true, in which case it should clear out the data. So let's refresh again and type out some gibberish, and now that data goes away. Great. So of course, in our input, we might want to have something like a placeholder here and say something like your name, and change this maybe to just simply name instead of your first name. And now, which case it now shows me your name in there, right? And so we can build out our form quite a bit more. And so the next one would be something like rx.text_area. And then we come in here, give it a name and say message, and then a placeholder. We could try the placeholder and say something like your message, and make sure you put these commas in here. Now, of course, when it comes to these inputs, all we want to make sure that we remember is we are calling essentially a form. So these are key value pairs that are coming in here for a Python function that would have a key equaling to something. Let's just say your message, right? And so there we go. We now have this data. I'm going to go ahead and put it in here. Once I see that, here is the actual value itself. Now, if you go into the documentation for this under core, you can see that the forms have buttons, checkbox, input, select, text area, everything that we just did. It's all in there. And you can see a lot of other form examples as well. Like in here, we've got a form stack. We've got the H stack also inside of the elements itself. So this might actually be nice because then maybe they have better spacing in here because we're using some layout feature that Reflex has in terms of VStack. So if I save that now, the spacing is a lot better. They were on top of each other just a moment ago. Now they're no longer on top of each other, in which case I can now build this out even more as I see fit with this value. This is pretty cool. This is a very straightforward way to just build out a form that is incredibly dynamic, as we've seen. Now, since it's dynamic, that means that we need to do something with this data, like store it into a database of some kind, or maybe send an email or something along those lines, which we'll see very soon. We're now going to create a root layout for our application. Now, I kind of did this backwards in the sense that page layout came first, but realistically, I would probably start with a root layout and then adjust it to page layout later. The page layout came as a result of learning about how we can reuse user interface elements. And we're going to do that same sort of concept now, but then eventually have our actual Navbar in here as well. So in the root of our project, I'm going to go ahead and create layout.py, and then I'm going to define my root layout in here, which will we'll take in one thing, which will be our child element, which is going to be rx.component. We will also have args and keyword args, in which case we will actually ignore those elements in here. So we're going to go from import reflex as rx. So the root layout itself is basically the exact same thing as our index layout. We'll just change it slightly in a little bit. So I'll go ahead and copy that index layout first. So what are the things that I want in here? Well, you might want this color mode toggle, you might not. I'm going to get rid of it altogether. The next part would be the actual child element that we would then put in here, which is just going to be child right there. In which case I may or may not want the Reflex logo. I'll leave it in for the moment. So this is our root layout now. And so the container also, I probably want to have other arguments in here, like maybe something like width equals to 100%, which we'll put in as a string. I also might want to put an ID in here, and I'll say my root layout, something like that. So we can take a look at what we're building here. So my root layout now is going to be the default layout for our entire project. So now I'll go ahead and do from podcast discovery.layout. We're going to import the root layout, and this is going to now be around every single component that we want this root layout for. So what this is also going to allow for, just like the page one, is to simplify a number of things. The first one is going to be this color mode. We don't need that. We don't need this logo. We probably won't need links in the near future. Maybe all we'll really need in this is the heading and the text and the button, just as a stand-in. I don't even need the link in there, but I will leave it so we can see what this looks like in a moment. So go ahead and save it and let it compile. We'll go into our home page and we'll just take a look. Hey, what do you know? It looks identical to what it did before. If I go and inspect the element here, let's go ahead and look for that ID. So I'm just going to do a quick search for the ID of my root layout inside of the inspected element with Command F. And there it is. There's that root layout right there, right? And so we see that it is basically the entire thing. Now, if I were to change it from being a container to being a fragment, the ID then goes away. You can't find the ID anywhere, but the root layout is definitely still there. So that's actually kind of nice. Fragments just simply do not render where the actual container itself renders as a div. Great. Okay. So the idea now is we've got this fragment here that's basically our root layout. I actually think our fragment is not going to be great for the root layout itself, but maybe over the child element. So rx.fragment around the actual child element itself if we needed to add in any other additional items to the entire project itself. Great. So the same root layout I can now use anywhere I want to. So in the case of our actual pages, the pages layout, it would actually make sense that I would also use the root layout in here as well. So that then when I need to make changes to it, that root layout would be reflected here. I don't have to do it this way, but the nice thing is then I don't have to repeat myself ever if I don't need to, like all of these navigation items that I have in there. But the nice thing about the layout function itself at this point is I could use the root layout if I want to or not. It's completely up to me on whether or not I'm going to use that in these different components. But now that I have these components, I can start that consistency by starting to bring in the navigation bar. Let's take a look. Let's go ahead and use the Navbar recipe directly from Reflex docs. So go into the Reflex docs, scroll on down to layout and Navbar. Also, if you do a search just simply for Navbar, you will find these same layout docs as well. And you're going to be able to pick which one you want. So in my case, I'm going to use basic at this point. I'll go ahead and grab the code, copy it, and then we're going to go ahead and create a new UI element called nav.py and then paste it in. The reason I'm calling it nav is because the actual component in there is called Navbar. That's the only reason. Otherwise, I would probably call it Navbar. Now we'll go ahead and import Reflex as Rx, and we're going to go ahead and bring this Navbar in to our now root layout. I actually meant to put nav inside of UI. If you don't have it in there, make sure that's where you put it. Now, the Navbar itself, I might use on all pages, I might not, right? So the nice thing about having it in its own component is exactly that reason. So the Navbar itself, let's go ahead and bring it into our root layout here from our podcast discovery.ui.navbar. We're going to go ahead and import that Navbar itself. And then right above the child element here, I can go ahead and bring this in and save it. And then what we should get is that Navbar. And so there we are. So we now have the container with the Navbar right above, and we can go through and see what's happening with the layout itself. So if we go into nav, we've got a Navbar link to home, which is fine. We got a about page. We've got a pricing page, which we don't have yet, which we can make really fast. And then we've got a contact page, right? So contact page should work. About page should work. Pricing page, not so much. So let's go ahead and create that pricing page by just copying about, call it pricing, and then we'll go ahead and say pricing page and pricing. And this is my pricing page and so on. Great. And so, of course, now, once I do that, I want to go ahead and make sure I am importing it here so that it gets registered in as the actual pricing page element so that the page ends up working. So we go ahead and refresh, and there we go. So now my static pages all have that same thing because of where we actually imported it from, right? So all of the layout for those pages is using that root layout container. Of course, if I were to get rid of it and do something like rx.fragment, then what we would see is those other pages would no longer have it. In which case we could come in here now and from podcastdiscovery.ui.navbar, we can now import that here. And maybe we want to put this in right in there. And maybe that's the Navbar we want for outside of the root layout. So if I go to the home page, this is what it looks like. I go to the about page, this is what it looks like, right? So now we have that flexibility if we want to, based off of whether or not we're going to use that root layout. Of course, if we do use the root layout, we don't want to duplicate that Navbar whatsoever, right? We just want to have that one single one and then bring that in. Now you do notice that when I did bring that Navbar in, it got rid of all of the other elements. That's because the root container, the root layout, only has one child element that it will render, and that's going to be the very first one. That's it. So now that we've got it, that's what we're going to stick with, something along those lines. But it still gives us the flexibility in our page layout, however we see fit on what we're going to do with that page itself. And of course, if you wanted that full page itself, we can just go ahead and do something like rx.fragment, and then we would bring in our navbar right above that container element in there, in which case it would go wide there, but then the inside would be a little bit smaller. So the actual layout, spacing, and all that is something you can play around with on your own. But at this point, I'm going to go ahead and leave it like this, where it's a container with that navbar. The only thing to note, though, inside of the navbar itself is you've got a mobile and tablet and desktop only. So it's quite literally made to be responsive. So if I were to bring it down and try to select one of these items, it's probably not going to go to any of them because we don't have them routed correctly. So let me just scroll on down here. We see that we've got these menu items on here. They are just not going to go anywhere at this point. So we would need to fix that. We left it off where our mobile nav bar did not actually navigate. So we want to change that now with a fairly straightforward process. I will say I go into a lot more detail on the navigation stuff in my full stack Python course, which does cover this. It's a little bit older, but overall it does still do a lot of the same sort of things that you might want to in terms of navigation state and all of that. So let's go ahead and actually jump into our code, and I'm going to go ahead and define, and we'll call this our mobile navbar link, which takes in just a URL string, and then it's going to return rx.redirect to wherever I want it to go. So this actually means that I'm going to use this as a event handler. So inside of my rx.menu content, I can go ahead and do on click and then put in a lambda function here with a colon, then call that actual function with the path that we want to use. And that will be our way of actually redirecting this user in here like that. I'll go ahead and do this at about, and then pricing, and then contact. There we go. And then this, of course, is going to be an event itself, but I think all of it should work just fine. So now if I refresh in here, break it down a little bit, and try to navigate, it looks like the navigation does work. And I should be able to go back, and it should also take me back. So let me just go home real quick, and then we'll go to about. I should be able to go back to home, and sure enough, it does. Okay, great. So of course, the next thing then would be, let's use that same idea on our heading as well. I'm going to get rid of the image and get rid of the image because we don't have one. You totally could add one. But again, I'll go ahead and do on click, and this one would be our lambda. And then we would go ahead and use, I can just copy and paste it actually. So let me just paste that in there. And we can use that same thing. And it's, I mean, granted, it's not the mobile nav bar link. It's more of just like a click event link, if you will. And we'll paste that in there. And this is going to be podcast discovery as the title. And there we go. So simple way to solve the nav bar issues. If you had them, naturally, if I now click over here, it does actually go back to my home page every time, as well as on mobile. So come down here to the drop down, and there we go. Great. So our navbar is well improved from what it was before. It's just a really simple lambda function. But if, like I said before, if you want to go into a lot more detail, check out my full stack Python course to learn exactly how to probably do this in a way that I think is still a little bit better than this, but this works. Now that we have forms that can actually generate data from our users, and we also have this sort of interactive button, I actually want to start storing this data. Now the way this is going to work is by using the Reflex database module. This is actually really easy to do, and it's built on top of a lot of pre-existing tools that are really good. One of those tools is called SQL Model, which also uses other tools as well. And there's another thing called Alembic. We'll talk about those in just a moment. But what I want to do right now is I want to spin up my own Postgres instance. Now, the Reflex docs shows us that we can actually use SQLite, which is fine for prototyping. But once we want to start getting towards production, you're going to want to use a production grade database, in which case we're going to be using Postgres for that specifically because we can do it locally and in production. So I'm going to be using the Docker version of this. So I'm kind of managing it myself, which has its positives and negatives, of course. If you want an in-depth look on how to use Docker, take a look at my Build, Deploy, and AI Agent with Python and Docker, which uses a lot of the similar tools that we're going to be using here. in the case of something like SQL model. Now, what we're going to be doing though is you can also use a managed data service like Tiger Data, which is also known as timescale.com. And then also you can use Neon, either one. The result here is you're going to create a database somewhere. In the case of Neon, if you were to create one, you would end up getting a connection string just like that. So that's actually pretty cool. It's a really easy thing to do. And then you'd be able to use that database as you see fit. And of course, Neon would then manage it. Now, there's costs associated with using that one, so you may or may not want to use that one. In my case, I'm going to go ahead and use something very similar to what I did in this course right here, which is inside of compose.yaml. So we're going to be using Docker Compose and compose.yaml. So essentially, this database service right here is what we'll be using. So I'm going to go ahead and copy that code here, and I'm going to bring it into my local project, and we're going to go ahead and do compose.yaml, and we'll paste this in here. I need to put in services right above this, just like that. And then we're also needing to put in volumes, and it's going to be the Docker managed DB volume, which I'll go ahead and just say my DB service volume, something like that. And then we'll go ahead and paste this one in here, just like that. Okay, so what we've got here is now a database URL connection string, or in theory we do. So I'm going to go ahead and bring this into a .env file here and paste it in. Now in this case, I'm going to be using my local computer to connect to it. So I'll go ahead and say localhost here and just make sure that compose.yaml has these ports in here and all that. So I could go into this a lot, but the point here is we should be able to do Docker Compose up, and it should be able to build out our database service for us. And it should run something like this, listening with this port like that. And then we should be able to connect to it here very, very soon. So the idea also when it comes to using Postgres in terms of Python is we need to install something called the scopg binary. And this is version 3. There's another one that's called version 2, which is I think scopg2-binary, which we are not using. We are using scopg binary, which is why in our .env file, I've got this connection string right here. If you were using a managed service, you would probably need to add this plus scopg in here for what we're going to be using later. Now, this has everything to do with the fact of how seamless Reflex makes connecting to these databases, because they've abstracted it away, and all you really need is this connection string, this connection URL. So in the next part, let's go ahead and actually take a look at how we implement this connection string into a Reflex project. So at this point, you really just have a database that's available to you and this database connection string. In that last one, I added my Postgres database into my project with this .env file here. And you notice that this is the connection string as to what it starts with, and this is how it connects. These two things are required. The .env file is something you're going to want to put into gitignore as well, right? So you're going to want to do that before you push it into GitHub, because otherwise, if you're using a production managed database somewhere else, that actual GitHub, that .env file will be loaded into your GitHub repo and thus exposing how to connect to your database. You're going to want to avoid doing that as soon as possible. I wanted to mention it now because those of you who are using a managed Postgres service, you're going to want to switch out this to being your connection string, because now we're actually going to connect it into our Reflex project. I will leave my .env there as a example that you could actually use as .env.sample. So going forward, my .env will not be on the GitHub repo at all because I will be making changes to it. So at this point though, I'm going to go ahead and update my requirements to use something called Python-.env. Now I really like using something called Python decouple, but not everyone likes using that. So we're going to use Python.env because it makes it available for us to use the environment variables that Python has directly. So I'm going to go ahead and save that and then jump into rxconfig here, and I'm going to import a couple things. So first off, we'll go ahead and import OS, and then we'll go ahead and do our database URL equals to os.environ.git and this database URL. So as you may know, this is how you load in environment variables in your Python project. You basically never want to write in your secrets like a .env file. You never want to write these in directly into your Python code because that exposes it. Like I've already shown you, we've already done that. So the idea then is once we have this database URL, we would go ahead and connect it into our configuration. And that's almost the end of it in terms of the database URL. The next part is I actually want to go ahead and do import, or rather from, this is going to be .env. We're going to import load.env and just run load.env before we actually use this method right here. So before that actually works, we need to make sure our virtual environment is activated, which we can check by doing python-m pip freeze, and it should only show our virtual environment stuff in there. And then you'll go ahead and do pip install-r requirements.txt just to make sure our other stuff are in there as well. So now that we've got that, I can actually go into the rx config and just print out our database URL here. And then in which case I could go into our Reflex code and go ahead and just simply run Reflex run, and we should be able to see that database connection string. Great. So at this point, all we would do is run Reflex db init just to make sure that our database is initialized and created and ready to go. What it does is it creates this Alembic folder here and also alembic.ini. What this will allow us to be able to do is run something like reflex db make migrations and then reflex db and migrate. And it should be reflex db migrate. Now, it's not migrating anything yet. It's not making migrations to anything yet. All we did was really connect our Postgres database into Reflex before we actually start making database tables, which we'll do very soon. But of course, if this part's not working, if you're having any errors in here, if let's say, for instance, you said ABC for your database URL, and then you try to run the migrate, you'll probably see something like this, right? You'll see an error happened because you don't have all of the things correct. Now, another thing you might end up seeing is if you didn't install Postgres correctly, or the binary for Postgres, let's go ahead and uninstall it and just see what that looks like. And I'll go ahead and say yes, and then try to run it again. It's now going to say it has nothing called scopg. This will allow for that to end up working. And the other problem that you might have, let's go ahead and bring in our installations with pip install-r requirements.txt. The other thing, the error that you would probably see is in your .env. If you just have Postgres there, you don't have the plus scopg, and then you run make migration again, it says it doesn't have scopg 2. That's the reason, is you need that plus scopg to use the newest version of it. That's just how it ends up working, in which case we want to save our .env here, and there we go. Great. So at this point, we're now ready to start building out our database table. We're now going to create our first database table using a Reflex model, which of course is based in SQL model. We'll take a look at it in just a moment. Before we jump in though, I will say that I ran git remove cached of .env, and then I made sure that my git ignore also had .env. That way my actual git repo for this project only has .env.sample, not the other .env. And even if the history has the old .env, that's okay. But I'm going to be using .env for other things, in which case I don't want it to be committed to Git itself. Great. With that out of the way, let's go ahead and actually create our first database model. Inside of contact here is where I'm going to put it. I'm going to go ahead and do models.py. So what I want to do here is I want to create a table, a database table, which is a database model. We want to actually store data in a specific way on our Postgres database. So the way this is going to work is we're going to do something like contact message, and this message itself will be of a specific class, which we'll look at in a moment, but it's going to have something like a name and message. So we want to declare just the name and message and the data type associated to that. This data is coming directly as a result of our form itself. So we've got our form state here, and then in our form, we've got name and message. And that's it. So those are the two fields that we're using. They're quite literally the same as what's inside of the form itself, which of course is done on purpose. So this is going to be our contact message. So what I want to do is I want to import Reflex as Rx. And then in here, I'm just going to go ahead and do rx.model. Now, before I go any further, I'm going to go ahead and inspect this by going and doing control click or right click into go to definition. And what we see here is we see SQL model. It's a base SQL model. It already has an ID field in there. So for those of you who are familiar with SQL model and know it well, you would know that if you look at the example in here, what you'll see is it says SQL model and table being true. This is still almost going to be true, almost the same thing, except we now don't need to declare our ID field. We would just be declaring the other fields as we see fit. That's why I'm showing you that. If you go back into the contact message itself, one other thing we need to do here is say table being true. By default, if we don't specify a table, you can do something like your contact message schema, or maybe like a create function here, in which case you can get rid of this. This would be for validation, something you might do at some point. I'll show you this in just a moment. But the idea is we now have this model in here. Now, in order for Reflex to know about this model, we need to import it somewhere. So let's say, for instance, in our form here, we want to import this model because we need to make sure that Reflex knows to use this model. So I'm going to go ahead and import it with an absolute import with, podcast discovery.contact.models. We're going to go ahead and import our, contact message model. Now, in this case, I might be like, oh, well, maybe I want to actually call this contact message model just so that I make sure that the actual class name itself is distinguished from anywhere else where I might be doing it. Like this one says form state, for example. So in this case, I will actually call it contact message model. And then in my form, I'll bring that one in. I'm not always going to do this in production or realistically, but I'm going to do it right now in this case. So we now have this model in here and it's pretty much ready to go. So what I want to do here then is I want to run reflex run db, or rather not run, but rather db init. I just want to make sure it's initialized. We should see this if it is initialized. Then we want to run our make migrations to create schema change scripts. Let's see what this means. So anytime you make a change to your models, you run something called make migrations. So then in our Alembic folder up here, we will see that those changes are being tracked. This is what Alembic does. It actually tracks the changes into your database. And what we can see here is it's creating the table contact message model with ID, name, and message. In other words, it's showing us exactly what our model has defined, and it's doing it for us in a very straightforward way. This is only preparing the database for changes, or realistically, it's preparing Python to create the changes in the database. To actually make the changes, we do something called reflex db and migrate. We hit enter. This will actually change our database tables, which you could verify in the actual SQL model itself. But what I want to do is I actually want to show you how to make a change to this model, because Reflex makes it really straightforward and simple. The way we're going to do this change is by using another field in here, which I'm just going to go ahead and import and show you what this field is. So I got a couple imports in here from SQL model. We're going to grab SQL model field, or rather just field. We don't need all of these. I've got SQL model and SQL Alchemy, the things that rx.model are based off of. And then I'm going to go ahead and create another field in here called created at, right? So created at in here has a default of timezone.now. So we're going to go ahead and import. So we'll go ahead and do from date time. We're going to import the datetime object, and we'll do it just like that. And so now we've got something along these lines of a datetime object. This allows us to have a time zone being true. I'm just going to say false just to get this working just fine. And if you wanted time zone enabled date time fields, you can just jump into the full stack Python code that I have, and you can actually come in here, look at the utilities here. It gives you this UTC now function, which is really easy to do. And then you can go into blog, and you would go into the actual model itself, actually, which is inside of models.py. And you can see this is the value right there. Not a whole lot different, but it allows you to have some time zone stuff if you wanted to do that. In my case, I don't. I'm just going to leave it like this. Now, we made changes to the models. So what we need to do is reflexdb make migrations, and then reflexdb migrate. So when you add new fields, you're going to need to have some sort of default in there or allow for it to be null. So for example, user ID is going to be an integer or none, or maybe it's just a string or none, right? There's a lot of different options on how we could do this, in which case we would do field and say default is equal to none, for example. that would allow for that to happen. And maybe we would also want this to be an index, in which case we'd say true, which is a database index, which means it just is a little bit faster in terms of the lookups themselves. And so we go ahead and make migrations again, and then we can migrate. So we need to specify that default field. And then of course you can look in the Limbic to see all of the things that are happening and changing for our actual database tables itself. You don't need to touch these things. Reflex, Alembic, SQL Model, SQL Alchemy are going to handle all of that stuff for you. This is really the only thing you need to worry about is the model itself, and then running stuff like make migrations and migrate when you need to make those changes. We now have our database model. Let's go ahead and store this data as a result of the form being used. So if we jump into forms here, what we're going to do is we're going to use something called Rx session. So we're going to go ahead and do with rx.session as session. This is a database session that will allow us to do stuff like session.add our instance, our object, whatever we are creating. So the thing we're creating, of course, is going to be our contact message model here. And the idea is we're going to go ahead and say the instance of that is going to be equal to that class dot model validate. We want to make sure the data that is coming from form data is accurate. So we can always set it to the actual state value, or I can just get the handle submit value in here, and then we would run through our session stuff. So what we do here is we're basically like prepare to add to DB, prepare to add to DB, and then finalize add to DB is session.commit, and then refresh instance object or Python instance with DB data, or simply instance.id, in which case we would do session.refresh. You don't have to refresh the data if you don't want to. I'm going to go ahead and refresh it. Then I'll go ahead and say self dot something like message, let's do message ID equaling to the instance dot ID, in which case I'll come down here and give a message ID of some kind. Now, the message ID, as you may recall, if we go into the model, is an integer. So we can think of this as an integer as well. In our form, we can say int, and the default is simply none. So I'm going to go ahead and set that one with this data in here. I'm no longer going to print out this data anymore, but what I want to do is on my contact form, I just want to verify that that data is actually coming through. So the contact form state, I'll go ahead and put in our message ID. I don't think toString works here, but let's go ahead and see if it does. I'll go ahead and save this, and we'll now take a look by doing reflex and run. Okay, so let's go ahead and actually implement the contact form at this point. Let's go ahead and take a look at the front end here now, and I'll just go ahead and take a look at this into contact, and I'll go ahead and say Justin, hello world. I got a null value down here. I hit send message, and we're getting one argument that we're missing. Let's take a look as to why. And that's because refresh, we need to refresh the instance itself. So that's one thing that I needed to change. Now, the reason that we have the ability to commit without the instance is because this is basically saving the entire session. Finish off the session, refresh the items in the session. That's kind of what's going on there. Okay, so here we go. Let's try that again. And Justin and hello world, send message. Now I see the ID. Again, some gibberish in here. Send the message. There it goes. Great. So it is now showing me that it is working, and it's adding those instance IDs. Each one of those IDs is automatically incrementing. This is a default for a number of things that are coming in. The main one being this is a default for SQL model. When you declare a primary key, an ID like this, it will automatically auto increment in a SQL database altogether on its own. You don't need to worry about that. The thing you would need to worry about is this created timestamp thing here, like we see here. Now, the other part of this is like maybe in our actual data, in our contact form, maybe we want to have that value in there as well. So let's go ahead and do Rx text, and I'll go ahead and grab, instead of just our message ID, I will go ahead and also put in our message timestamp. And again, this is going to be a date time object, which we'll set at being none by default. So I'll go ahead and import date time here. And then we'll go ahead and our self.message timestamp is going to be equal to the instance.created at. And of course, all of the syntax is already being filled out for us, which is pretty nice. And then down here, we'll just go ahead and do our message timestamp also toString as the text. And then we can go ahead and try this again and just fill out some stuff. And what we get is nothing coming back. So let's go ahead and see why. We've got module date time. Maybe, oh, there it is. This should be from date time, import date time. Little error with the data type itself, which is what's happening here, a checking instance error. And then we're going to go ahead and do this again. And now we can see those two objects coming through as their actual values, which is now showing us that we have this data in here, which is pretty great. Let's take a look at how we can put in something called default values into our form data. The idea here is I want to first off start with our message. I'm going to go ahead and say it's equal to a dictionary now. And so the actual message instance will come in here. We'll do the entire thing, which is instance.modelDump. This is a Pydantic method here that allows you to dump out the data, which of course, all of this data is based off of Pydantic. And so now in our text area here, we'll just go ahead and put in the message toString itself. Okay, so I'm going to save that. And of course, if I come in here and I put in some gibberish, I can run that and there's my message. So what you can do is you can do something called a default value. So in any input, you can set a default value in here, as in my init value, my initial value in there, whatever you want that to be. You can refresh in here and you can see that it actually ends up changing what it is once I go to reset. It goes right back to that initial value. This thing is nice for at some point when you actually have data stored in your database and you want to pre-fill a form itself. The way I'm doing it, the reason I'm doing it has to do with if there's an instance error, a model validation error. In other words, we're now going to go ahead and say something like has error, and this is equal to a Boolean. I'll go ahead and say true. So when you have a state value like a Boolean, you would actually end up coming in here with your form once it's being submitted, assuming that after it validates, we would then say something like no error. We would say something like then has error being equals to false. But for now, I'm just going to go ahead and return the value, which means that none of this is being run, and it's always going to persist as has error. So now down in my form here, I can do something like this, where it's rx.condition or cnd. Then I can set the condition, like my value, my Boolean, basically, and then the actual value we want to render, so my true value, and then the false value, right? So basically, if this happens, render this. If this does not happen, render that. So let's see this in actual practicality by using that state method of has error. So if I come in here and say state has error, then I'll go ahead and say the true value or has error is true. And then the false is basically the opposite of that. So I'll go ahead and say false. Okay. So what we see here now is it's rendering this out. This value right here can be any sort of Reflex component. So you can do rx.text and put it in here like this, and then do color and red. I think red is one of the colors that you can use. And then we'll put that in. And then now we would see in here what that color is, and it's now showing red. So we have some sort of form error in here now, or at least the start of it. Now, why am I talking about these two things? Well, it actually has to do with how we do this default value here. So right off the bat, I'll go ahead and say the init name value is going to be equal to rx.condition. And what is going to be the condition? Well, it's really going to check if the form data itself has a value for the name. So I'll go ahead and do form data.get, or rather the contact form state.form data.get name. And if it does have a value for that, we'll go ahead and use that one. Otherwise, we'll use an empty string. Don't use none. You want to use an empty string because of how inputs work. They are always going to be either a actual value or an empty string. So that's what we're going to put as our init name value. And so now if I were to refresh in here, I can see that that value is in there. I hit send message. That value persists in there because I never took it away. So if we look back in here, that form data is going to persist in here. So if I wanted to change that, all I would need to do is we'll come right after has error and return now. All I need to do now is do self.formData being empty. Okay, and so now let's go ahead and refresh on this. I'll go ahead and run it one more time. We submit that. Now it says false and that data is gone. So it is still resetting the form. I didn't change this whatsoever. All I changed was the initial data that's being filled in the form itself. So we'd want this with our message data as well. So init message value, which will be the same name as the field value itself. And then we'll come in here and do that same sort of default value of what that ends up being. So again, I can come back in here, put in some gibberish, and then it resets altogether. If I get rid of that reset and I persist the has error in here and I put this data in, it now says it has an error, as we see like that. So of course the default value is going to be it does not have an error, and what we want to see here now is maybe a function that says like clear form data, or like maybe a reset form takes in self, and then it's really just going to be a couple things. It's going to be these two right here, and then we'll go ahead and leave it as is. We could also do something along the lines of resetting the message if we wanted to clear that out as well. I want to persist that message, but the idea is down in here, after the session happens, we would then do something like self.reset form. But of course, if there's an error, a validation error of some kind, then we would want to return and not reset that form. That error would be in there altogether. And so if we wanted to correct this or make a problem with the validation, is maybe change the name here to something different, and then we would actually get a validation error. If I run that now, it's showing me that it has some sort of error in here, but the data didn't necessarily persist. So let's go ahead and say inside of this exception, we'll now say something like has error being true. This reset form should not be true, but rather false. And then this should return with that error. And we can also print out what that exception is. We'll say exception as E, and we'll go ahead and print out e.errors like that. Okay, let's go ahead and try that again. We'll refresh in here. Now it's showing us that error, and it's saying this message, the actual field is required in there. Great, so let's actually expand on these form validation stuff. The main thing here is to basically persist the data that's being submitted temporarily until the entire form needs to be reset. And of course, we could always have a button that allows for me to reset it as well. So something like, rx.event, and then we'll do something like, handle reset button. And in which case it would be self.reset form, and then also maybe self.message equaling to an empty dictionary itself. And we need to pass in self here. And then of course we'd come down and create a new button in here, which would be potentially next to this button. And it will go ahead and say something like reset. And then instead of being submit, it'll just be a button. And then on click, we would call that state element. So contact state form, and then handle reset button. Great. And so now I'll also do rx.hstack and put these two into a horizontal stack here. And then now we've got a reset. If I click on that, it resets everything. If I come in here, hit send message, great. It's showing us that validation because of course we do have an error. Let's get rid of that error because we don't want to leave it on an error, but there we go. And so again, I can reset it. That part is not fully necessary if the data is fully there, but now we have conditions, reset, and also sort of persisting the form data itself, at least until we go to reset it, which I think is a good part of all of it. We're going to use Pydantic to do some validation on our data coming in and have some basic handling so that our form is a little bit more robust than it currently is. This is going to be basically the last step in the form usage. So inside of our models here, I'm going to go ahead and bring in something very similar to this context create model here, but instead I'm going to use Pydantic. So from Pydantic, we're going to import the base model, and I'll go ahead and pass this in right here. So all I really want to check here is I want to validate the field here. And the way we do that is by using something called a field validator. And so we want to bring in this decorator from Pydantic, and then we declare what field we're going to validate, which is going to be the name field. You can have field validators on all of your fields, and you could do a bunch of things with it, which I'll show you in just a moment. And so with this in mind, I'll go ahead and also make this a class method, and then we're going to define validate name, which takes in the class and the actual value itself. And then basically we can just add in our validation. By default, you would return back that value. The validation itself, we would say something like if Justin in val.lower, then we'll go ahead and raise the value error, name cannot contain the string of Justin. And then I'll put this in as a string value here. And instead of a semicolon, we'll use an actual colon. Okay, so that's a really simple way to do some validation inside of your model. So where do we use this and how can we actually use this? Going back into forms.py now, we will go ahead and import that contact create message. And now I'll come down a little bit and grab this instance here. This is no longer the instance. This will be something like our actual model data is going to be something along those lines, right? So this one will be model data now, and we'll go ahead and use the model create in here. So the instance itself will take that model data. It's going to be very similar to it. And then I'll go ahead and call this. And now I can just go ahead and initialize that model data.model dump. The reason I'm not also doing a validation here is because this is going to be doing the validation for me. And that's pretty much it, right? So this is now checking if it has errors. This is going to be storing to DB as is, right? And it's going to do all of the other model data stuff that you might need to do. So this right here is probably fine. So once we have errors, we would see that. Then in here, we would reset the values. So all we need to do is really check this name if it ends up working. So going back into our contact form, let's go ahead and invalidate the data by passing in my name here and send this message. And we see that it says true or false error. So this is where you can then go even further on your validation for the form itself. Like there's a lot of different ways on how you could go about handling this. I'm going to just go ahead and copy and paste some of those values for you so you can just kind of see it yourself. And so I'm going to come in here and grab the exception and just replace this with this validation error exception, which comes from Pydantic. So I'll go ahead and do from Pydantic, import that validation error. So what this will do is it give you the ability to have a errors dictionary here with the actual errors themselves, which will come through all of the different fields in there. Otherwise, you can have a general error in here and render that one out, in which case your reset form here would be something like errors equals to an empty dictionary. I'll let you fill that out as you want to, but the point is we have errors here, and now the error message would be there was a validation error. Please try again. Something like that, right? And so if I refresh in here, I can see that now when I run this, it says that there was a validation error. It looks like I might have had a little bit of an error on the actual part here. So let's go ahead and this is has error, not has errors. Let's just reset those there. Okay. And so once again, I'll go ahead and submit it and says there's a validation error. Please try again. Great. So it actually is doing the validation, and it's doing so based off of what's being submitted in here. And I'll just put a G at the end of my name, and then we'll go ahead and do Justin, and there we go. That's incorrect. You cannot use my name that way. Okay. And so now that we've got that, we've got all of our errors in here, and the rest of it should work as it did before. This time though, when the contact message is empty, I'll just go ahead and put an empty string here. We might be able to get away with none or just simply rx.fragment, which is another option that you can put in there as your conditional value. Reset in here. Now the message doesn't show up at all. And of course, now when I go to do something different, it then works in here. There we go. So that's some simple validation. This, of course, could be a lot more powerful in terms of what we display to our users. But I think it's still important whenever we start storing data into our database, we want to do some sort of validation. And the reason I ended up using Pydantic's base model is, of course, it's basically the same thing as our actual database model, which is a key part of that as well. But the reason I use Pydantic is because then I can actually take it out and do something more like schemas.py. And this is actually where I would store this data, is I would put it into my schemas here and only have my Pydantic related schemas. And this is now our contact message create schema in here. And that's actually how I'd end up using it instead. So then we would come in here from podcast discovery .contact.schemas. We import that one now. And then we just make that slight change. So then our models are for database specific things, not Pydantic specific things at all, but just the database and like that. So with Reflex, the models themselves, you could do table being false and be able to do some of these schemas as well. But in the case of Pydantic, especially when I'm validating data, I like using Pydantic directly like this, even if there are shortcuts to using it otherwise. So there we go. We now have some schema validation in here, and we are now ready to really start building out more of the different things that we might want to store in our databases themselves. In this one, I break down the challenges into rolling your own user authentication. It's a little bit longer, so feel free to jump ahead if you want to start the implementation process. But I think this is important to understand why I'm not rolling my own user. We now want to implement users into our project, and we're going to do so by using Clerk. More on this in just a moment. Now, if you wanted to actually build out your own user models and a user login, you actually now have a lot of the foundation to make that possible. So going through the intuition, you would basically have another model in here that you would call user, and then you would have something like a username, and then maybe the message instead would be password. And in this case, you probably wouldn't have a user ID because if you remember, the Reflex model already has that ID field in there. And then once you have that user model, you would then create a form, much like our contact form, which would take in form data, and then it would allow you to basically do some sort of login on this form submit. You could also do it to create a user. Now, this is technically possible, and you might want to experiment with doing this because learning how to do user auth yourself can be really interesting and useful. However, there's a lot of flaws to it. The very first one would be how we manage passwords, or the fact that we even have passwords. But if we think about how we would manage a password in its current state, we would be storing passwords as raw text. So ABC123. This is not good. This is very easily accessible from the database itself. Now you could upgrade this by using a hashing algorithm or an encryption algorithm, maybe something like a salt, where it would actually change it to being something a little bit more like gibberish. That is not at all salt, but the idea being that you would use something to kind of transform it into something else and then store that something else. That is definitely where you would want to go. Now, if you were using something like Django, that is sort of built into Django user management, which is really nice. But there's a whole nother step that maybe you're not necessarily thinking about when it comes to passwords. If you go into a login form, let's pretend this contact form is a login form right now, and you go to handle the submit data, you've got this form data right here. Something that is super easy to do on accident is to print out this form data. Now, when it comes to data that doesn't need to be secured in any way, as in basically any other data than passwords, API keys, or any other sort of sensitive data, printing out that form data and have it accidentally being exposed in your running logs, not that big of a deal. But when it comes to passwords, this is really easy to accidentally do, and thus exposing your users' passwords. If you do it for any extended amount of time, this becomes a big problem. This means that you actually expose a lot of users' passwords. And even worse, if you were to have something like email in here and you actually have them log in through their email and password, users might actually reuse the same email and password on all of their services, thus making them very vulnerable to attacks all over and all over the place. Now, like I said, being able to implement this on your own is definitely a rite of passage and something you can learn about doing. And I think it's really awesome to learn about and really useful to learn about, so you fully appreciate everything that I'm talking about here. Now, this is just a pure user, as in a username and password or some sort of password-based user authentication that you're building yourself. What it's not doing is it's not allowing for OAuth login. That is stuff like Google login or Meta login, Meta/Facebook login, or X login, or GitHub login, or any of the other tools that are out there that you might want to use in lieu of a username and password. Doing this is definitely possible, but it also requires to handle callback URLs. So there's a whole nother set of things that you'll need to do in order to make just OAuth login work in this environment. The next thing is there's something else called single sign-on, which is very similar to OAuth, except the user needs to log into one centralized location and is just logged in already to your account. It's kind of like OAuth, but it's just a little bit different. But that is another thing that you might want to implement at some point, especially if you have an organization of some kind. Now, there's another thing called multi-factor authentication, which you're probably familiar with, which is like those SMS text messages that basically allow users to verify their account, which also means basically like a phone number-based login as well, right? So there's all of these modern login mechanisms that you might want to use in your project really soon. Users sort of expect this now going forward. There's whole other things like HIPAA compliance as well, which is like, for medical things, and at least in the United States, if you want to have some sort of user login for that, there's a whole nother set of laws and regulations you would need to follow, which of course, doing your own user auth most likely will not fall under the category of HIPAA compliant. So this is one of many reasons that we use Clerk. To me, the easiest one is just simply how easy it's going to be to implement ourselves. We'll see this in just a moment. It's really just a few API keys and one third-party package that we use with Reflex to just make all of this work and work fairly flawlessly based off of everything we've done so far. And you can implement all of these things out of the box, as well as things like organizations, where you can actually have users be a part of multiple organizations. That's not something I'm going to cover in this one, but the idea being that we have the ability to do all sorts of things out of the box with Reflex that you just simply can't do if you're trying to roll your own auth. Now, the biggest downside for sure is the fact that you are now using a third-party platform to manage your users, which means price or costs associated to it, which I think Clerk is very competitive here in their free plan. 10,000 monthly active users. That is 10,000 people that log in every 24 hours is free. If you have 10,000 users on your service or platform, you should probably have no problem using this free plan. And even if you don't, you can always move up and start to monetize those 10,000 users beyond that free plan, and even $25 a month to save you the headache of trying to implement all of this in a way that is secure and, well, really seamless to what we're about to do is, to me, one of the biggest unlocks with using something like Clerk. So let's go ahead and implement it right now. Let's create a free account on Clerk. Now you could go to clerk.com and just sign up, or you could use my link. If you've enjoyed this course, using my link just gives me credit with Clerk so we can make more courses together and bring them to you for free, just like this one. Either way, we want to use Clerk here because it's going to be a really low friction way to have users and get your project out there much, much sooner. So go ahead and sign up for your free account by going into sign in and select your login. I'm going to be using Google, and then I'm going to see something like this. Now, one of the things you'll notice is Clerk uses Clerk to log in to Clerk, which of course makes a whole lot of sense. Now, in our case, we're going to jump into the documentation. One of the things that's going to stand out to you in the documentation is it's really around a lot of JavaScript stuff. And down at the bottom somewhere, there is Python. So realistically, so much of Clerk exists in the web browser on the client side. Just like Reflex has a client side and a back end, Clerk itself is a lot of times in that front end environment. So that's why you'll see in the docs so much around JavaScript itself or any sort of client application. So like Chrome client application that's not on the server, iOS, same sort of thing. Now, the idea here is I go into a lot of depth on learning all of the Python of it all on my Unlock users across any Python or JavaScript stack in this course that's free right there. You can always go through that one, which is a lot more nitty gritty of specific things for Clerk itself. In our case, we are looking at the implementation. So let's go ahead and create our first application here. In this one, I'm going to call this my podcast discovery app. And all I really want here is going to be Google. I don't even want email. I just want them to log in with Google to have this seamless login. Now, on one hand, you might want to have something like Apple because they do so much with podcasting, but I just want Google. If they don't have Google, well, frankly, they'll either sign up for a free account or they just won't work with our system. The nice thing about all of this is we can add more later at any time. If you want to add a phone number later, you totally can. It's really easy to do. I'll show you that in just a moment. So I'm going to go ahead and create this application, and you can see so much of it is about the front end. It makes a lot of sense that Clerk itself is a very front-end focused service because that's where your users are going to interact with your application on the client side, on the front end. So if you go into Clerk and you look at the question mark here, go into the documentation, you will see that there's a bunch of SDKs or software development kits for that front end, for where the users start interacting. But of course, if you scroll down, you'll start to see backend technologies like Express, Java, JavaScript backend SDK, and also Python. Now, in that last portion, I mentioned a course. That course goes into this Clerk SDK for Python quite a bit. One of the things you could do with this SDK would be to actually create a user model in Reflex and sync that user model with the Clerk data however you see fit. I'm not going to be going over that one in this one. What I'm going to be doing is actually implementing Clerk using a Reflex package called Reflex Clerk API. So if you do a Google search for that, you'll see the one from Tim Child. Now, I happen to know the guys at Reflex, and they mentioned this is the one to use. This is the one, if you want to use Clerk, use this Reflex Clerk API package because it's really good. But of course, if you wanted to build your own, you totally could, in which case you would need to wrap React. You would actually need to use the Clerk SDK for React.js, then actually wrap it to be able to work with Reflex. So if you want to go that route, by all means, go ahead. It provides a lot of customization that you might want to do, but it's well beyond the scope of this course. If you want to see how we can build out our own custom React components for Reflex, let me know in the comments. Otherwise, let's go ahead and implement the Reflex Clerk API. This is going to be so easy. So if you go in the documentation here, you scroll on down, you see the pip install command. I'm going to go ahead and grab this command right here, and we're going to jump into cursor into our requirements.txt. I'll bring that one in there, and then I'll go ahead and add in Python. I'll leave in the environment variable stuff in there. I'll go ahead and make sure that I have my virtual environment activated, and just by checking that I've got Reflex in here somewhere, there it is. And then I'm going to go ahead and run pip install -r requirements.txt just to make sure that that actually gets installed. Okay, so next step from this package, we can see the usage here. I'm going to copy their usage, and I'm going to go ahead and bring it into my project here. And what I want to do is I'm going to go ahead and create a new folder inside of my project. I'm going to call it providers. Inside of here, I'm going to go ahead and say something along the lines of my Clerk API, or let's call it Clerk provider.py. And then I'll go ahead and paste this in, and here we go. So I need to import Reflex in here as Rx. And what I want to do is I want to use this Clerk provider here. So it's coming from the package that says the Clerk API. I usually put this in as reclerk, mostly to think of it as Reflex Clerk. That's kind of the idea. So I kind of changed the documentation there so that it doesn't have Clerk itself. Now, the reason for this is for me sort of future-proofing what the Clerk SDK for Python might end up being. Right now, it is not simply Clerk when you import it, but if you look in their documentation, what you'll see is it says from Clerk backend API. At some point, it might be just simply Clerk, in which case I don't want these packages to conflict with each other, so I'm not going to call it that. Then we're going to go ahead and do import OS, and then we can see we've got some stuff for this provider. So I'll call this my Clerk provider, just so that it doesn't get confused with the Reflex Clerk API provider, and then we'll go ahead and use that very soon. Now, I realize some of you might not have any idea what's going on here just yet. I'll talk about it in just a moment. But the idea then is we've got a publishable key and a secret key. So I want to make sure that I get those things, and I absolutely want to register this user state. More on this in a little bit. So where are these environment variables coming from? Well, first and foremost, in my .env, I'm going to go ahead and paste it in here, and then I'll go ahead and paste in the secret as well. Now, typically speaking, when I go across something that's a public key, I change it from being publishable to just simply being public, just so that I know this one's public, this one I can share. It's okay if it's on the front end, it's okay if it's exposed. Where the secret key, not so much. So I also have this in our samples here, as you can see, but that's how I name it, just to make it slightly different and also to understand what's going on, in which case I'll now put it in just like that. Okay, so where do we get these keys from? Well, of course, we need to go into Clerk, into our application, go into our configuration for it, and then you're going to want to scroll on down here to the API keys, and what do you know? There's our public key that we can copy. We can bring this into our .env here now, and then we'll scroll on down to our secret keys, which we can copy and put that into our .env. Okay, so we're close. We're not quite there yet, though. So what we want in our Clerk provider here is we want to use this as a base component, something like putting in a child component in here, which is going to be rx.component. So the child component needs to be inside of this provider here. And then what I'm going to do is I'm going to get rid of the container, and I'm going to do rx.fragment. And then in that fragment, I will put that child element in here. This provider now, I'm going to bring it wherever I want to be able to have access to my users, which is basically everywhere. I'll go ahead and bring this provider into my base layout, my root layout now. If you recall, this root layout is used everywhere. So in our main index page, there's our root layout. In all of our other pages, we have that other layout called root layout, which takes in very similar things in here. But this time I'm going to go ahead and bring in from my provider. So I'm going to go ahead and do an init method here. And then I'll go ahead and do from .clerk provider, import my clerk provider, and then just export that one as well. And then my clerk provider, I'll just copy and paste it here like that. So then in my layout, then I'll just go ahead and do from podcast discovery, we'll import providers so that I can then now go in here and do providers dot my clerk provider and then wrap basically everything else inside of there, in which case I now have that clerk provider activated in my different pages. Now, I'm not sure if I'm all done yet, so let's go back into the Reflex Clerk API code here. This is our usage. If we scroll on down, we're not seeing a whole lot beyond this, right? So there is actually documentation in here as well that I think will continue to be improved on. But if you go into the getting started section, you will see a lot of the same sort of stuff. So here's the index thing, and then here's the pages. So all I really wanted to see was to make sure that, hey, this is how I can add those pages in. And now I've got this clerk provider. Now, there is another thing that you could do is you can actually wrap the entire app, which is essentially what I just did. So I essentially did wrap the entire app. This is a convenience method that may or may not be supported in the long run. So this is me wrapping that entire app. This is done in a very React.js kind of way where you have providers above the application itself. But of course, I don't want to spend too much time there. But the idea being, if you need additional providers, you could always add in those additional providers right in here like this, or you could have some sort of master provider that you create, like you would do something like base and then do my provider and then do that same sort of child thing and then put in all of your providers in here that you might want to. I'm not going to do that because I'm really just having this one provider here. But the point of this provider is to give us some features that we will need to actually log in with Clerk, which let's go ahead and do that right now. Let's go ahead and add in some login and sign up buttons to our Navbar. So first and foremost, we'll go into nav.py. I'm going to come up here and do import Reflex Clerk API as reclerk. And then we're going to go ahead and create some buttons here. So inside of the desktop only, we see the Navbar links here. I'm going to go ahead and just do rx.button, and we'll go ahead and say something like sign in. Okay. So once we save that, we can see it adds a button here. Now we might want to drop the spacing a little bit because I'm going to add another button here like sign up, and we'll save that. And of course, these buttons now look the same. So I want to change them slightly, in which case I'm going to go ahead and do a variant. And this one's going to be simply outline. And there's all the variant options. you could always go into the documentation for the buttons under the API reference for this button. You can see all of the different things that you can do in terms of props for the button itself. So feel free to check those out in terms of the arguments or props for the button. Okay, so now we've got these two buttons in here, and I want them to actually work based off of reclerk. It's really simple. We just use reclerk dot, and then we can use the sign in button. There we go. There's for sign in. The same concept with the sign up button. So let's go ahead and do sign up button. And there we go. So now if I save this and hit sign in, it takes me over to Clerk to sign in. I hit continue, and then I select my account, my Google account. I'm going to hit continue, and then it'll bring me back into my Reflex application after it finishes the login portion. Now, it's not really clear that that happened, but it did. We will look at that very soon. All I really wanted to see here was how simple it is to create these buttons, right? If I go to sign up now, hey, what do you know? It actually didn't sign me up. It actually didn't do anything there. So I'm going to add in one more button then, and I'll go ahead and do my, let's say, log out button or sign out button. There it is. And we're going to go ahead and say, I'll call this one log out. Okay, so it's going to add another button there. I hit log out, logged out. If I click it now, it doesn't do anything. Now, if I go to sign up again, it then asks me or prompt me to, continue with whatever it is that I'm trying to sign in with. And then it goes through that same sort of process that I've already done. Fantastic. So of course, how do we toggle between these two things? Well, this is actually really cool about reclerk as well. We can actually just go ahead and do something like this. We'll go ahead and do rx.fragment, and this fragment is going to be our logged in fragment, right? So everything in here is our logged in fragment, or rather logged out fragment, and this one is going to be our logged in. So you want to log out when you are logged in, okay? And so all I need to do then is inside of this fragment, I'll now do reclerk dot, and we'll go ahead and say signed out, and that's going to be all of this stuff. So if we're signed out, this is what we're going to see. If we are signed in, this will be the button we see. Save that. Now it shows me log out. I hit log out. Now it shows me sign in, and then I can hit sign in. Fantastic. How cool is that? So it's really just showing me this process. Let's now go ahead and welcome back our user on the home page. So the way this works is I'm first going to log out just to make sure that I have this standard page in here. Next up, what we're going to do is we're going to go ahead and import the Reflex Clerk API as reclerk, and this is what we want to use. So there's two APIs in here that we can use, which is reclerk.clerkState and reclerk.clerkUser. And if you look at these in the code, what you'll find out on the documentation, if you do a quick search for clerk state, you can see a bunch of different parameters that are in there. And of course, if your actual code is set up correctly, you can look at the code directly inside of your text editor as well. But the idea is we've got a is signed in here, and this will be a Boolean value. As soon as you see something like this, especially inside of Reflex, what you want to do is say something like our welcome message is equal to rx.condition. So we already have a Boolean value, which can be is signed in which case we would say something like welcome and then hello, right? So that would be our welcome message. Of course, we already have a heading in here, so I'm going to go ahead and put in that heading as my fallback if they're not signed in which case we can now come in here and change our new welcome message. Of course, if I go to my home page, it doesn't look like anything has changed, and I can actually toggle this in here as I see fit. But of course, as soon as I were to go log in then with my account correctly, what I'll end up seeing, of course, is something a little bit different, and that says just simply welcome. But I still want to make it a little bit more personal than that, in which case I can now use the clerk user directly. So if we look at the clerk user here, we can see things and attributes about this specific clerk user, first name, last name, and so on. So going back in here, I can now say instead of just welcome, I can use some string substitution in here and do, our reclerk.clerk user and then dot first name and put an exclamation mark, in which case I'll go ahead and put these on multiple lines now so we can see these new values in here. We'll go ahead and save that. And now what we'll see is welcome Justin, which of course is the user first name for the account that I've been using. It just so happens to be my name as well. But that's a really simple way to do this Boolean of what's going on. But of course, the next question would be is, how do I actually store this user data when I go ahead and send some data into our backend? We now want to use the clerk user to actually store their data into our database. So the idea here, of course, is looking back into our models.py under contact. We have this user ID field here. This is what we actually want to set. Now, we've already kind of seen how to use a user, but we've only seen how to use a user in the front end. Whenever you see rx.condition or cond, that's going to be rendered out on the client side in the front end. This isn't going to work the same in the back end, which we'll see in just a moment as to why, or basically what's going on, or what you'll see if you try to use it. So the first step, though, is to ensure that our model, our user ID model field here, is correct. It's actually organized correctly. So if we look back into our clerk state, we go into the definition, we see our user ID here is a string. So the clerk user ID is not an integer like I declared earlier, but rather a string. So no big deal. Let's go ahead and just change it inside of our models.py. I'm going to change this to str. Now I mentioned before, anytime you change those models, what you're going to want to run is reflex db make migrations. But of course, when you go to do this, it doesn't seem like anything changes, except I did change the data type. So let's go ahead and rerun reflex. So I'll go ahead and do reflex run, hit enter, and then let's go ahead and take a look at our contact form in here. We'll just navigate into our contact form. Let's put in some message in here, hit submit. We now get this programming error. This is because I changed the data type itself, but Alembic didn't understand this change. So this is where when you actually have data types themselves and you do something like this, the way I do it whenever I want to change a major data type is I just literally remove that field and then I'll go ahead and do it all over again. If you need to persist that data, if you need to create or save that data, then I would just rename the field and then create the new field in there. So now that I've got the field being removed, which is what this migration ends up doing, is it drops that column. Since I don't have any data yet, and of course we're still in development here, this is not production practice whatsoever, I would then bring it back and leave it in as str, make those migrations again. This will bring back that field in there, and in which case I can come back into my contact form once again. Let's go ahead and reflex run it again. Then I should be able to come in here and submit some data. Now in my case, I actually deleted my database to just restart fresh all over again. As you can see, I've got an ID of 1 now. But of course, now we want to set that user ID. So the intuition at this point would be to jump into forms here and grab our user ID. So let's do something like rx.condition and then say something along those same lines that we had before. So we'll go ahead and do import our Reflex Clerk API as reclerk. And then you could come in here and grab reclerk dot, our clerk state. And now I can just go ahead and say user ID directly. If the user's logged in, we will be able to get the user ID themselves. And then I'll just go ahead and do that. And otherwise, I'll just leave it in as an empty string. So I'm going to go ahead and print this out now. I'll go ahead and print out user ID is that. And what we should see in our statement here, if I refresh with some gibberish, submit it, it did store some data. If I look in the terminal, this is what I get. So if you ever see something like reflex state, and all these underscores, instead of the actual value, that means that you're using some sort of front-end capability in the back end. So the way this works, the way we can actually grab this state is by changing it to an asynchronous function, in which case I can now say, for instance, our clerk underscore state equals to await the self.get state of whatever that state object would end up being, which in this case is going to be this one right here. We can take this same concept with our clerk user and say something like our clerk user. And in which case, this is no longer going to be how we do that condition. So let's go ahead and just take a look at the clerk state, and I'll even get the type that's coming through here. We'll go ahead and save that. I'm not changing anything else on my backend form. I hit submit. Looks like all the data is still being stored. I look inside of my print statement here now, and what I can see is at the very end, I get a class of that clerk state in there that I'm able to use. And of course, I can always verify and review what that clerk state class is. But what I want to see now is basically I'm going to go ahead and try to do .user ID. Notice that it's already trying to give me that user ID in here, which I think is pretty nice. So I'm going to go ahead and print out that user ID now, and we'll just go ahead and say user ID. We'll save that. I'll refresh in here, run this again, hit submit, and what we should see is the user ID. Great. So it is showing us the user ID. And of course, I could always get the user data in there as well if I needed it. I don't need it at this point, unless of course I could come in here. Actually, I will show you how I use it in just a moment, but we'll go ahead and take a look at just the user ID. I want to log out now, go back into contact, run this again, hit submit. What I should see is none. So it's already doing the Boolean for me. This is either going to be a user ID or not, in which case down here I can come into the instance and say, if there is a user ID, then I can do instance dot user ID is equal to this value right here. Now I can also pass it into the model itself or just update it later, which is what I'm doing. We could also put it into the model dump itself. So we could say cleaned data like this and equals to that dumped data. And then we can pass in the user ID here. And I'll let you finish that out, but it would basically be the same process. But there we go. So now that we've got this, let's actually see if it stores that user ID in there. And we'll go ahead and refresh on here. I need to, of course, log in. So let's go ahead and do that. Log into our user. Click on that button to log in. And then, of course, we'll navigate back into our contact to see if it works. So we put in some gibberish and there we go. So we now have user data that's being stored in here. I do like that the Reflex Clerk API gives me these built-in buttons that will automatically start some sort of flow. But in some cases, you might actually want to have a full-on page to render this out. That's what we're going to do right now. So first and foremost, I'm going to go ahead and jump into my project, and I'll just go ahead and create a new module called Auth. And then in this module, I'll go ahead and do init.py, and I'll just go ahead and say pages.py. So the idea here is to take the base layout maybe, or any other sort of root layout that you might want. So let's go ahead and do that with from our podcast discovery.layout. We're going to go ahead and import the root layout there. And then we're going to also import Reflex. And we'll also import the Reflex Clerk API as reclerk. Okay. And so naturally what we're going to start off with here is going to be maybe our sign-in page or our login page. I'll go ahead and call this my login page, and it's going to return back rx.component. And then we'll go ahead and do our root layout in here. And then we can do something called rx.center. This is actually really nice on how you can actually center elements from in here. We can use reclerk dot sign in. So not the button, but the actual component. And that's pretty much all we'll need. When it comes to center though, we also might want to add in a minimum height. In this case, I'll do 85 vertical height or 85 VH. So basically the box itself around this will be at minimum 85% of the viewport height. So with this in mind now, I'm going to go ahead and just do from.pages. We're going to import that login one, and we'll go ahead and do our all here and put in that login page. Then on our main root application here, we will go ahead and do from podcast discovery, import auth. And then I'll go ahead and use inside of app.add page. You can do auth.login page, and then we'll go ahead and declare our route. Okay. And the route itself is going to be /login. And so now when I go back into my project and I go into /login, I should see the login process. So this is where I could then start that process. So you can now put this anywhere, that actual button and all that anywhere with this right here. And so naturally we can take this same concept a few more times. So the other one would be like our sign up page, and this will be sign up. And again, not the button. Okay. And then the logout page, this one will be the button. So we'll call this the logout page. And so I'm going to do this one a little bit differently by doing rx.vstack. So vertical stack. And then we'll do rx.heading and something like, are you sure you want to log out? Something along those lines. And then I'll do rx.hstack. And this will be rx, or we'll do reclerk here, and then .sign out button. And then I'll do the rx.button, and we'll say yes, log out. And then I'll put another button here, which will actually be rx.link, and it'll be rx.button. And then it'll go, no, cancel. The reason it's a link is because we'll just go ahead and go back to our homepage after that. I'll also give it a different variant, which we'll just go ahead and say outline. And let's make sure we've got all of our commas in here as we need. And it looks like the VStack one does not have a comma. Okay, so with this in mind, I'll go ahead and now bring these into our auth method here. So there we go. We got all the imports and exports for the init method. And then I'll just go ahead and duplicate this a couple times. And then we'll go ahead and do sign up, or maybe join, and then log out. And sign up page. Logout page. Great. So now that we've got this, the other part I would want to change is in my nav. Instead of having the buttons automatically do this, I'm going to change these to being links. So rx.link, and this is going to be sign in. That will be to href of login. Now we'll go ahead and change that from sign in to login, and then rx.link and href sign up. Now, the reason I'm doing this is mostly for if you want those pages, and then also the logout page, I think is something that's nice to have as well to confirm. So realistically, I'd probably most of the time have just the logout page. I wouldn't necessarily have the sign up and sign in page, but I do get a navbar with them once I do that. So let's go ahead and verify this is all here. So now if I go back into my project here, I click on login, there's that login, I go to sign up, there's the sign up, and it now of course has the actual nav bar itself. So when we go through this process, it will of course log us in, and then I can now go into log out. Are you sure you want to log out? Yes. Very soon, we're going to implement a sidebar, or basically a different layout when our user is logged in, so they can see more of a dashboard than what we've got right here. The way we're going to do this is inside of this clerk provider here. So what we can do inside of here is we can change what's being rendered in the root layout based off of the condition for this user. So what I want to do here is I'm going to go ahead and say non-user layout. And this is going to be this one right here. And then I'll go ahead and say my user layout, which will basically be the same thing, but I'll remove the navbar right now just to show these two different layouts here. And so by default, we can still keep in that non-user layout in here. And you might keep it like this for good. What I'm going to do is take it a little step further and say something like Reflex Clerk API as reclerk again. And I want to actually come in here and do a couple of things related to this. So the first one is inside of the provider. I'm going to go ahead and do the same thing that's in the documentation, which is adding the spinner in here. So I'll go ahead and do that with reclerk loading. And then we'll also do clerk and clerk loaded in here with reclerk. And that's going to be our non-user layout, right? And so that's basically taking place of those buttons here. So on one hand, we have the signed in and signed out, right? So that's another option that we might want to consider with how we run this. So we could come in here and say the user signed in. So we'll go ahead and do reclerk signed in. Otherwise, we would do the other one, reclerk signed out, right? And we'll put a comma here, or reclerk and reclerk. Or better yet, we'll put our user layout there. Okay, so now we've got a rendering for our root layout that will take in our non-user layout and then our user layout. So in here, what we could do is we could define a non-user layout and basically return back this itself. And that's probably a little bit better so that then if we do need to focus in on this, we would, in which case it would still take in a child element here, in which case it's still an Rx component, and it would return back an Rx component. In fact, both of these would, so we would probably want to put that in both places. And then of course I can bring this down, and instead of having that one, we would then just go ahead and do our non-user layout with that child element coming through, and then repeat that same process with our actual user layout as well. Not a big deal. I'll get rid of that navbar, and then we'll come down here and pass in the child element as well. I'll get rid of that one, and there we go. We want to revisit our clerk provider to see if this is really going to be the best method for us in the long run. Now, first and foremost, we actually see an error with that provider. It says it takes one argument, but I gave two, which I did right here. That's a really easy fix. We can use rx.fragment around this, and that solves that specific problem. But the thing that I'm really getting at here is the fact that maybe I want to use the reclerk or the Reflex Clerk API anywhere in my app, and I should be able to do so. Like if I don't want to follow along with this root layout anywhere in my functions, I want to still be able to use everything that I've got here. And so I just want to modify one thing really quick, which I really appreciate that the Reflex Clerk API developer thought about this. And that is, I'm going to go ahead and now add in my clerk provider args and just pass in it as a dictionary here. So this is going to convert this stuff into a dictionary, in which case I'll still use it inside of my clerk provider. But now with these provider args, I can do something really nice as well. So go into our init method here. I'll go ahead and bring these two things in, make sure I put a comma there. Then we'll go ahead into our root project here. So what I'm going to do is go ahead and say from the podcast discovery.providers, I'm going to go ahead and import that my clerk provider args so that I can come down here. And we also want to make sure reclerk is in there. It sure is. I'll do reclerk and then dot wrap app around that and then unpack those items. Now, every other route have access to that clerk provider. And so in my root layout here, I no longer need to provide it at all. It will just work. So we did talk about this when we were first implementing it, but now it's a very real thing that we are going to want to implement. And so that's why I'm doing it now. Now going forward, at any point in the future, if I want to use something like the user layout, I don't really need to worry whether or not it's inside of my own provider. It's just going to be available for me anywhere I need to. And that Rx fragment is still doing its job because we only want to return one single component, which is exactly what that's doing as well. And so if I were to take a look at my project now, I can see that everything seems to be in order in terms of it running. One of the things that's not really showing me is my user layout, and I have these two backwards. So I'm going to go ahead and replace them to being in the right order so that our user logged in looks like this. And then when we go to log out, let's go ahead and actually go to log out. In here, we can see that I can log out, and there we go. So now it's in a position to start building out the root user layout or the user dashboard. Let's do a quick recipe search for sidebar. And what we want here is one of these sidebars that we're going to use. In this case, I'm going to be using the bottom user profile here, mostly so that I have this and also the logout method itself. So I'm going to go ahead and copy the code here, and we'll go ahead and jump into our project under our UI. I'll go ahead and do sidebar.py, and we'll paste this in. Now, this is called sidebar bottom profile. I'm going to call this my user sidebar, just so that I know that's exactly what it is. And then we'll go ahead and import Rx or Reflex as Rx. And there we go. So now with this user sidebar, of course, I will go into the layout, the user layout itself for this one. So we will go ahead and do from our, podcast discovery.ui, or rather .ui.sidebar, we'll import the user sidebar. And then in here, this is where we'll end up doing it. So right now it's a container. I'm going to change this to being a box. And then we'll go ahead and bring in our user sidebar here, and we'll take a look at what happens to our project, assuming the user's logged in. Sidebar showing up, the content is now down here. That, of course, is not what I want, so this is a good time to use something like rx.hstack or horizontal stack with the items in between. And then a comma at the bottom. I'm going to get rid of rx.logo, and then I'll go ahead and take a look. Now it's side by side. So if I actually want the sidebar to be the full height, I just need to jump into the sidebar under the desktop only and the VStack here. If we scroll on down, what we will see is a height in here at 650. If I change the height to 100%, it might go all the way down. It also might not. To make it go all the way down, we just do 100 VH, which is the vertical height, which is going to be up and down. And there we go. So now it's actually showing up correctly. And of course, if I go into the home page, I can see that coming through. So it's actually starting to look pretty good. In terms of the links themselves, these are not great, right? So the logout page, I'm going to go ahead and change this to /logout. And we'll go ahead and say logout instead. Settings, we simply do not have a settings item, so I'm going to get rid of that. And that goes away. Now I've got the logout button, and I should be able to go to logout if I spell the link correctly. So log out, there we go. And so now if I click on it, I should be able to go to, it didn't reload yet. But anyways, so saving that, let's go ahead and jump to the next part, which would be our other ones. This will be our dashboard, which I'll go ahead and say just simply dashboard. And we'll go ahead and leave that as our main item there. And then I'll go ahead and do something like contact and put in /contact, and we'll get rid of these other ones for now. I also don't want the logo on there any longer because I don't have a logo at this point, so feel free to change it as you see fit, and also feel free to change the mobile version. That's something I'm not going to worry about at this point, but you definitely could do it. I don't really want to spend much more time on that. So here we go. We've got our dashboard and our contact, and I can actually navigate a little bit in here. Obviously, the user stuff is not quite there yet, so we want to maybe put that in as well. So let's go ahead and take a look at what that user icon looks like. So if we come in here, we've got this H stack here for all of our user data. So the H stack is what I'm actually going to change into being its own component. So I'm going to go ahead and cut it out, and then we'll call this our user sidebar profile, and we'll initialize that. Let's go ahead and define it as our user sidebar and profile. And then we'll go ahead and do our rx.component response. And of course, it's going to return back that same sort of information. So this is another reason as to why I wanted to bring in the wrapper for the entire Reclerk application. So that then now I can actually come in here and bring in our Reclerk API, which is what I'm calling it, of course. And then we'll come down in here and we've got our H stack in here, right? So the first one is going to be rx.condition. And basically if the user will use the tilde reclerk.clerkstate.is signed in, as in if it's not signed in, then we'll put that first one there, which I'll just go ahead and do rx.fragment. Otherwise we'll do the entire H stack that we had before, and then we'll use our clerk data from there. So what we've got here then is if I look at this, the user should show up. And if I were to take away that tilde there, the user data should turn into a fragment, as in it goes away. And so I want to keep that in there so that I can now adjust my H stack and then change these things as I see fit. So I can leave it in as my account, or I could do something like our reclerk.user, or rather clerk user. And let's say, for instance, our first name. And I can go ahead and say a string substitution here. And then just put a something like this, Justin's account, which is what it'll end up saying for me. There we go. And then I can use that same idea with the user's email. This time I probably don't need to put anything else on there. And I'll just go ahead and put my email address in, and there we go. And naturally, there is a way to check if there is an image for this user. I'm just going to stick with that icon at this point, mostly so that I now have basically a dashboard going on. But I'm not quite done yet, and that's because there's this big gap here that you may or may not want to have on your dashboard elements. The simple way to solve this is going back into your whatever page is being rendered. So if there's an RX container here, we can adjust this to have a different size. Let's say, for instance, a size of 4, which would make it rather large, which brings it a lot bigger. And so that is how we can actually bring that in terms of our size. And so you could also use rx.condition here if you wanted to bring in different conditions or different sizes for a container based off of what user's being used. I'm just going to keep all of my containers at that size. We could also go with that same method that we did with our pages, where there already is a container and all of the pages would basically use that, in which case you would then have a default size for all of your different elements throughout your project. So now we've got this contact page. Notice it's a lot bigger. We've got our dashboard page in here and all that. Of course, at this time, I probably don't need any more information in my contact page. So in there, I could probably get rid of some stuff from the page itself, which I think is actually in the pages layout here with these different links in here. I'm going to go ahead and get rid of all of that. I no longer need that. All I really need are those two elements. And now our contact page looks a little bit better. That input value I would leave for this just to make sure that when I am logged in, I can see that there is a user ID here, which of course correlates to that. Now that user ID, maybe that's another thing you want to bring into the sidebar as well, just to verify things while you're testing, right? In which case you would just come into that user profile again, and then you could just do the same sort of text here. This time for the user ID, it's going to be our clerk state and user ID. Right, and so now you should be able to see that come through down in here, which this is not ideal, so I'm actually not going to keep it myself, but you totally could, and you can even bring it down a size. Maybe that solves that problem by making it a little smaller. It's still a little too big for what I would want there, so I'll leave that out. But the idea, of course, is now we have the ability to have a little bit more of a robust dashboard, and then, of course, if I were to go log out, I can log out, and here we are back on that other page on there, and then I could go back and log in, and in which case it would then show me that dashboard once again, which of course is ideal. We're now going to go ahead and create a podcast search form with Reflex through the iTunes Search API. Now, iTunes itself as an application no longer exists, so I'd imagine at some point this process will probably change. But the thing is, I think a lot of applications are built off of the iTunes Search API, so I'd imagine it's not going to change anytime soon. That being said, I did go in a lot of detail on how you can use this Search API in my Smarter Web Scraping with Python course, which is available at this link right here, which will also be in the description. I also have the code already available for you for this course, our podcast platform course. It's in the helpers function, which is going to be able to make the API calls for you. Now, at a high level, this is actually very straightforward on how it works. First off, we have a base URL that we're going to be making an API call for. We're going to encode our URL, and we're going to format the search based off of all of the different parameters that are available to us from the iTunes Search API, which then gives us this URL that you can obviously go through and figure out. Then you can do your podcast search based off of that URL. You just use Python request to do a search, and then it has a timeout in there, and then it will filter and do the results here. As far as Python is concerned, this is a very straightforward request. So if you're not familiar with this, definitely take a look at the actual Smarter Web Scraping with Python and AI course. Otherwise, for the rest of us, let's go ahead and actually implement the functionality now. So in our podcast discovery, I'm going to go ahead and create a new folder called podcasts. And inside of this folder, we'll go ahead and create an init method. And then I'm going to go ahead and create my form.py. And so the idea here is I want to do first off, a class called my maybe my podcast search state, and it's going to be rx.state. So we'll go ahead and do import reflex as rx. And what is it that we want here? Well, we want our results, and then we want a query. So the query itself will have a default as an empty string. The result is going to be a list. Now, when it comes to rendering out this data, which we'll see later, we also want to have a data type inside this list. So what we need to do is we want to bring in from typing, we're going to bring in the list element itself, and you can always bring in any as well. So in other words, you can have a list with basically anything on the inside. In our case, I already know what it's going to be, and that's going to be a dictionary value, which is coming from the iTunes API, which is going to return back JSON results in here. It's going to be dictionary data coming back for sure. And so I'm going to go ahead and give it a list, or basically set it equal to none as the default, because we won't have any results just yet. So with this in mind, I'm also going to do rx.event, and this is going to be simply our handle search method here, which will take in self and form data. And then what we want here is we're going to grab the query directly from the form data itself, which we would do something like that. And then we'll go ahead and call the search API. We'll do that very soon. Next up, what I want is just to create my search form itself, which is going to go ahead and come in here, and it's going to be rx.component as a response. And then we're just going to return rx.form, and then of course on submit, and that's going to be equal to the podcast search state dot the handle search method here. And then the inputs themselves, well, it's going to be a search form. So we'll do rx.hstack, as in a horizontal stack. And inside of here, we'll go ahead and do rx.input. And then, of course, is going to be a type of text. We'll give it a name, and this name should equal to what we did up here, which is going to be that query. And then we'll go ahead and put a placeholder in search for podcast episodes or something along those lines, however you see fit. We are only going to be searching for episode titles, not the actual, episode show or who is putting it on. Next up, we're going to go ahead and bring in our button, which of course will be a type of submit. And then we give it a label of some kind in here. And I'll go ahead and say search podcasts. Okay. And let's go ahead and make sure we end that. And there's our search form. Great. So far, so good. Now, how do we actually use the iTunes Search API? Well, I already brought this in as a handler, so I can go ahead and do that podcast search by coming in here and doing from podcast discovery, import helpers, and then we can actually get our results. And this is going to be equal to helpers.podcast search of that query. We can also put in a limit here of how many results we want back, which we'll say 5. I can also change various things like an attribute. So if I wanted to have something other than the title term, which would be the podcast title itself, you can actually go into the search and you can see various attributes that are available to you, which are going to be all of these right here. So you can search for languages, authors, artist, description might be the other one that you might want to use on here. I'm going to stick to something easy and just leave it in as the titles. Then, of course, after that, we do self.results, and we're going to go ahead and say that's equal to the actual query results. So you could say API results here just to make sure that it is a little bit different in your mind. And then we can go ahead and say if API results, we'll go ahead and print out the API results there. And in fact, I want to grab the 0th element, so I'll go ahead and say if the length of the API results is greater than 1, then I'll go ahead and grab that, or rather greater than 0. I'll grab that first item in there so we can see exactly what those results are. So now that we've got this search form, let's go ahead and bring it into our homepage here. So we want to make sure that our podcast has an init method. Sure enough, it does. And I'll just go ahead and bring in from podcast discovery, .podcasts, and then .form. We're going to go ahead and bring in our search form here. And I'll come in to my index value. I will go ahead and leave the actual welcome message, and I'll get rid of all of the other ones. We just simply don't need those anymore. I will initialize my search form. if everything was done correctly, I should see it compiled. I'm getting this warning tag for the dashboard itself, which is just a small, minor little warning related to the sidebar element for the dashboard itself. So if we did a quick search for it, dashboard, there's that sidebar item. This is the icon itself, which you could always verify by the ordering for that sidebar item. As soon as I do that, I should see my local host being slightly different. And there we go. So now I've got my dashboard contact, and then I've got my search element here. If I do a quick search for Django, obviously nothing shows up here, but in my print statement, I see all sorts of things. So really the key here now is to render out the search form or the values from it based off of the search state itself. But the actual podcast search itself does actually work. And so we can see that by looking at this data here. And you could always take a look at the key values that are coming through so you can see what data is coming back. So if we do another search, we can even do gibberish there. It might come back with something. Let's do something that's real, like Python. Do a quick search for that. And there's our values, our key value pairs that are coming in from this data. This is going to help inform what we end up doing for our tables. But that's how we can do a quick API search. Granted, this API, we didn't go through building each step of it, but the API itself is just doing a request itself to the API endpoint. There's no authentication needed. We don't need to log in or anything to use the iTunes Search API, which is one of the big reasons why I think a lot of applications use it, because it's so simple to get going and it's pretty powerful. So let's take a look at how we can start rendering out this data.
We now, of course, want to display our search results. So we're going to use a table and a loop. So the way this works, of course, in Reflex, we're going to go into components under tables and data grids, select a basic table here. Of course, there are more advanced tables, but we're just going to go based off of this one. I'm going to copy this whole thing and we'll jump back into our project and go ahead and do table.py. And then we're going to go ahead and just define it as our search results table. And then we'll go ahead and return back that value or that data. And basically we just need to make sure that table root is the root element there. Of course it is. We're going to now go ahead and import Reflex as Rx. And there we go. Okay, so we've got our headers and then our body. So when it comes to the table header, I typically will hard code these, and then the body will be the one that we will actually loop through. The way we do this is we're going to define something called our search table row, and that's essentially going to allow us to return back the row itself. So I'm going to go ahead and cut one of the rows out, and there we go. So now we've got our row in here, and it's going to be all of those rows coming through. So all we really need to do then is we need to pass in some data in here, which is going to be our dictionary value. So the data that's coming through will be of a data type with a dictionary. And then we will go ahead and come down into our body, and we want to do something called rx.forEach. And then we're going to iterate through all of our data. So initially I'll go ahead and say something like we'll start it off with like maybe a ID, and I'll do 1, 2, 3, and then title and ABC. Okay, so I'm literally putting a hard-coded list here just for an example. And then after you have the value there, that's when you have some sort of callback function that will handle that value, which is going to be the search table row. So the list element itself inside of there is going to be the dictionary. And then, of course, we've got a list in there with dictionary values, which is how it loops through. And then down in here, what we can do is we can do something like, data.get and title. And that will allow us to loop through the table altogether. Naturally, we will actually integrate this into our project very soon, but I really just wanted to show the example as to how this works. So going back into Podcast Discovery, into our homepage here, we've got our search form. So right underneath that, I'm going to bring it in. And so we'll go ahead and do from podcast discovery.podcast.table, import let's see, this should be podcasts.table. And then we've got our search results table, and it can be rendered completely separate to the search form itself. So now when we go into our project, what we should see is the actual search form table rendering something. So it actually shows us that title that it's rendering and then the other data. So naturally I could come in to that and just change this to my new title, and then I can copy it all over again and do something along those lines. And then what we should see is a new row actually rendering out right after that. So now we need to just unpack our actual state data into this same sort of for each. So this is how you can do those for loop values. You basically take the list or the iterator in there. It doesn't have to be dictionaries inside of there, but you will need some sort of callback function to actually render out the data that's coming through. One of the things I really like about Reflex is how you can break down basically every component to be really focused. So in the case of our state here, I can actually cut this out and then go into a state.py file, paste that in, and then of course inside a form, we'll probably need to have some things in there like the Reflex import. I think that's all we really need other than the state variable itself. So I'll just go ahead and do from.state, we'll import our podcast search state. The relative import should work just fine, even though I typically like having the absolute imports in there, but I'll use the relative import for now. Okay, so what we've got is our search state, and this should still render. We should be able to still come in here and do a search for maybe Django, or better yet, let's go ahead and do a search for Python and Reflex. Let's see if there's any podcasts for that. But of course, it's not rendering, so we need to render it. Now, the way we're going to render this is going to be inside of our table that we will now import that state. And what we want to do is go ahead and grab that state dot results. So naturally, this can actually iterate, you can actually loop over, because the results itself will be either a list of dictionaries or none. So one thing that's important here is that we are declaring dictionaries in there so that then our row itself can also declare dictionaries themselves. So basically, if we had a list of strings, we would want to adjust the actual table itself to be based off of that. And I'll go ahead and say no to that, and we'll turn this back into dictionaries. So the other part about this results is it can be none. So that means then right off the bat, I'm like, okay, if it can be none, then I'll go ahead and do rx.condition. And of course, the condition is whether or not there's results. So basically, we would say the search results, and then from that, we would then do our iteration. Otherwise, we'll go ahead and say no results found, or something along those lines. Okay, and there we go. So we can save that. And then if I do a search in here and do something like Django, or what did I call it before? Reflex and Python, do a search, and maybe I'll see results, maybe not. It doesn't look like I did find any. So this time I'll go ahead and say, Django and ChatGPT. Let's see if there's any results for that. Doesn't seem like there is, or at least they're not rendering. There's a Django search, and of course now we get a bunch of rows in there. Okay, so the search results will vary, of course. That all depends on the iTunes Search API and also the things that we are searching. Right now we're searching the title term. If we actually change it to maybe the description term, we might get a little bit better values in terms of the search itself, in which case I'll come back into my state and we'll change it to being our description term in there. Okay, great. So the next thing what I want to have in here inside of my state is the query. So by default, it's an empty string, right? I also want to do something like maybe loading, and we'll go ahead and say Boolean being false. And so then on my initial search, what I want to do is say something like self.results equals to none, self.loading equals to true, and then we would come down in here and bring in self.loading equals to false. And then of course we want our query in there being stored as well. So self.query equals to that query. And there we go. Okay, so now back into our table, we can obviously have a bunch of iterations for this as to what we would end up displaying in here. So let's go ahead and do something like our search results rows. And now I can go ahead and say, here's my conditions. And then I can also do no results found for query and then our search state.query. And there's going to be my rows in here. So the reason I even have those rows has to do with doing another condition. So rx.condition, and then we would come in here and we would basically say if it's loading, then we would do a spinner. So we can do rx.spinner. Otherwise, we would do, after that, we would come in here and show those results. So the only reason I did it this way is so that we're not stacking the conditions all inside of here. This basically gives me that same thing. In fact, I could also turn that into its own method here. So we can say search results rows and then just return back that condition. Same sort of thing, right? And so once again, we are basically making these things really narrow as to what they end up doing. And then I can now make it a actual component itself, which of course all of these are Rx component, which we would probably want to return back as well. Great. So now we have a loading state that will show us that, hey, it's doing a search, and then the results showing up in here as well. And maybe we would want searched for somewhere in the near future. So no results found for query. So once again, we could probably do like our query label, and let's go ahead and add in one more thing where it's like rx.condition, and we'll go ahead and say if there is a query, then we'll go ahead and say the like entire string here maybe, and then we'll go ahead and grab that. And then otherwise we'll go ahead and do something like search for a podcast. Search for a podcast episode. And there we go. So now we've got our query label or our no query label in here, in which case we should probably see search for a podcast episode. And now I'll go ahead and do a quick little Django search, and there that goes away. And this could also come back to maybe the entire table doesn't get rendered based off of the query and all of that. I'll let you kind of decide how you're going to approach that. But of course, the idea here was mostly to be able to display these results. Now, part of the reason I printed out the iTunes API result keys is so that I can see all of the different values, the actual keys I can use to render out one of my rows. So if I actually were to paste out this list here and make it a little bit different as a doc string, what we see here is all of the different keys that are available to our row. So we can do stuff like the title is not actually title, but it's going to be more like track name, right? And then we also have something for release date. Maybe we want to also put in release date. So we would actually do, data.get and the release date. And then maybe we would also want to have something like the collection name. Where did that go? This collection name right here, right? And then maybe even the track URL itself, the actual location as to where you can play it. And that's going to be not necessarily the feed URL, which is another one that's pretty interesting, but it's going to be the preview URL maybe, or the track view URL, or the episode URL. There's a lot of different URLs in here. I'm going to go ahead and put the episode URL right next to the track name. And we'll try that one out and see what it looks like. Okay, so now I've got 4 rows in here that are coming through, which means that I need to have 4 columns for the table itself, which are these down here. So I'm going to go ahead and add one more in here, and we'll paste it in. So we're going to go ahead and say track name, or maybe title, whatever you want to call it, of course, episode. So we'll go ahead and say audio, and then our next one is going to be release date. And then finally, we've got collection name. So we're going to go ahead and say maybe podcast name, or podcast show, or show name, or something like that. But however you do that is going to be completely up to you. As soon as I make that change, I can see in my table here, I'm now seeing all of these values in here, right? So I can do something like, entrepreneurship in there, do a quick search for that, and you might see some really good ones. You could do, I think it's called My First Million. Let's see if that actually does a result. Because again, we're only searching podcast descriptions, which may or may not give us the valid results. So in here, what we've got also is like release dates from a long time ago. So it's not necessarily ordering these things as you might want, in which case you can actually do this sort by date in here as part of the search itself. So going back into the state, we can say sort by date being true. This, of course, is going to be based off of the limit, the amount that you end up searching. So if you end up searching a lot more, but then only storing or reviewing those results, so let's go ahead and say something like up to 20, then you can actually do a much different search altogether. This is where playing around with the API might be something worthwhile. So if I do a Django search again, now what we should get is more recent ones. Granted, we've got this long list here, so I got to scroll over to see the more recent ones that are released from this stuff, right? And again, it's actually doing a pretty good job in terms of doing searches for all this. Ooh, I should check out Huey. That looks pretty cool. But the idea here is we now have a way to display our data based off of what's coming through. Now, in the long run, what I would want to do is make the data a little bit more dynamic than what we've got. So in other words, I would actually come into the state and I would grab these keys and set them as maybe my columns, right? And this would be a list of strings then. And then I would set that equal to basically an empty list to start out. And then I would go ahead and do something like self.columns equals to those keys. Or better yet, I would have some sort of key mapping where it would be something like title, or we would grab the map, which was, let's go ahead and go back into our table. We would grab something like track name, right? And then we would map that to title, which would then mean that our columns themselves, we would come through and do x.get let's say y, and it would be for y in, or it would not be x.get, it would be key mapping.get for y. And then that would give us the column names that are in there based off of all of those results. I'm not going to do that mapping, but that would allow you to have some more dynamic mapping for the columns. And then everything we just did, you could then loop through all of the titles for the columns. And then, of course, once you actually get the data itself, you would loop through that as well. So that's outside the scope of this one, but it is pretty nice that we can now do a quick search for a podcast of some kind, and we'd be able to see those results. Reflex makes it really easy to have an audio player, so let's go ahead and take a look at how to implement this now. Inside a podcast here, I'm going to go ahead and do players.py, and we're going to go ahead and define our podcast audio player. And what it's going to take in is maybe our podcast data, which is going to have a dictionary in here, and then we'll go ahead and do a key, which is something like our episode URL here, and then we'll go ahead and start the process of building this out. So we're going to import Reflex as Rx. The audio player itself is rx.audio. And the reason I have the dictionary here is mostly to basically get the podcast, let's say our episode URL value equals to the podcast data dot get that key. And then I'll go ahead and pass in this as our URL that would come through in there. Realistically, though, I would once again want to have rx.condition and say if the episode value is in there, then I'll go through the rendering process. Otherwise, no audio found. And there we go. So now we've got our URL coming through. The actual audio itself might need to have a height and width. So I'll go ahead and give a width, let's do width of 150 pixels. And then we'll do a height also. And this one will be like 32 pixels. Okay, so there's our podcast audio player here. Now let's go ahead and bring it into our table. So we'll go ahead and do from .players, import our podcast audio player, and then we'll come down into the table row itself where it's being rendered, which is right here. And then we'll go ahead and say our audio, let's say element equals to the podcast audio player. We're going to pass in the data dictionary, and the key is, what do you know, episode URL, which of course is written right there. And in which case I can now use this as my cell in there, and that should help us render out the audio itself. And of course, if I were to play it, I should be able to hear the actual podcast themselves. So we now have our own custom podcast player itself that works off of the iTunes API. And you could probably download things in here as well. So notice that there is still that button to download the actual audio from here. But overall, we now have a way to just simply play it. Now, every once in a while, you'll also see something for videos, right? So if there is a video URL in here, I don't see it right now, but you could also play videos in a very similar manner. You probably could even try to use rx.video in the same way. Let's go ahead and see what that does. So if I were to go back into the player, and I'm going to go ahead and copy this, and I'll go ahead and say something like podcast video player, and we'll just change this to, well, still the condition. This one should be video right here. This time the height, I'll go ahead and give it a little bit more of height and width rather, and then we'll go ahead and do something like that, and then we'll go ahead and say new video play found. Let's go ahead and see if this one works the same way. So we'll bring it in as one of our players, and then we'll go ahead and do just that real quick swap in there, and we'll refresh. And what do you know? It's still rendering out the audio in here. So if it actually was a video, it would probably render out the video. Again, let's make sure that everything's correct in here. And this is just a browser-based one. Pretty sure if I use a different web browser like Safari and paste that in there, what I'll probably see is a much different look because I'm not actually logged in. But let's go ahead and do a Django search here. And then now the audio player looks a little bit different, but I think it will still end up playing it. It might buffer a little bit differently, or maybe it just doesn't play it at all because it's an MP3 file. So that's where testing on different browsers will make a difference when it comes to stuff like this. And so let's go ahead and try that with the audio player now on both browsers. There's that one, and we refresh on our Safari one, and there it goes. Okay, so definitely different based off of the browser, which this may or may not be the one you want to use in the long run. You could always download these files because they're just simply MP3 files. You could save them yourself, and then you could play them from your source or some sort of audio delivery source, which would be outside the scope of this series, but the idea is still very much there. The other thing about this is the fact that they are MP3s is you could download them and then transcribe them and then offer like little clips. You would even be able to use AI to offer little clips and stuff like that. So if you want to see that, let me know in the description. But that's the audio player as well as the video player. Now we talked about this key mapping in our API results, but we could actually do something a little bit more effective and get us closer to actually storing this data in our database. So inside of podcast here, I'm going to go ahead and create schemas.py, and then I'm going to go ahead and bring in some Pydantic stuff. So from Pydantic, we'll go ahead and import our base model, and we'll go ahead and use a field here. And then I'm going to go ahead and bring out my podcast episode schema. And this is going to be our base model. And so the idea here is we want to make it very Pythonic. Right now, the API itself is not very Pythonic. So if we actually take a look at the table, this right here is using something called camel casing, which is how these are cased out. We want something called snake casing. So for example, the track ID, this right here, we would come into our schema and we would change it to being track ID. And the way we change it is, of course, we could use integer. I'll actually set it as a string because of the track ID itself. We would need to verify what actual data type it is. But I want to actually set it as a field with an alias being that track ID. Now, the reason for this is that the incoming data will be track ID. The result for us, for our purposes, will be track_ID. That will change the key value itself. So taking this logically, we would actually expand it on all of the other fields we want to keep track of. In this case, I have the track name, episode URL, our release date. We'll look at that in a moment. And then a few other items that we might want to have that, of course, are coming from this value here. So once we do that, I'm also going to go ahead and import date time. And actually, I'll do the from date time, import date time value itself like that. And there we go. So we've got our fields, we've got everything that we want. And then I also want to add in some config here, which is going to be populate by alias being true. And then we'll go ahead and do from attributes also being true. So this will allow for me to actually have some configuration and use those aliases themselves. So to put this in action though, we want to actually go back into our state value. Now I'll go ahead and do from.schemas. We're going to import that podcast episode schema, and I'm going to change my result data type. The result itself is going to be something like this schema. So the idea here is we could either do it in results and change the actual results, or we could save maybe the raw results still and save that as a dictionary or none and equaling to none. In which case I would just come down here and save those raw results, and I won't even cut them down. I'll just save the raw results altogether. But of course, if there are actual results in here, I want to now update the results I'll render out to use that schema, a list of that schema. So naturally what I'll need to do is update my data here. So the raw results I'll go ahead and put right underneath the API results now. And then if there are API results, I'll go ahead and update my actual results based off of the schema. The way we do that is we grab the podcast episode schema itself, we unpack the dictionary value, and we'll do this in a list comprehension just like this. So of course, this is how we would unpack it, and now it's a list of those data types. So very similar to what I talked about with that mapping, but now it's all in this schema here, which means our table needs to change as well, because the table right now, the data type it's expecting is simply data. So once again, we'll go ahead and bring in the schemas here. So we'll do from.schemas. We're going to import our podcast episode schema. This is now our search table data here. And then I'm actually going to change this to being simply podcast. And then I'm going to use this in a few different places. Now the audio player itself is still using a key value pair. I could totally change that as I see fit, but I'll leave it in as dictionary, in which case I will use basically the same data in here, but I'll actually set the data URL itself. So this is now episode URL. Okay, so that's now going to be that data. So down here it says podcast.get. We don't need .get anymore. We can actually use .notation for the item itself. So trek name. And this helps us a lot with completion and will just help us not run into errors. So like release date. This is also now a date time object, so we'd be able to format it if we wanted to. And then of course, collection name in there as well. Great. So now we've got the podcast episode itself. So if we scroll down, I shouldn't have to do anything in here. Basically, all I really need to do is make sure that I'm actually using the schema data types correctly. And I don't think I have it in anywhere else. It's not in the form. It's not in the audio player itself. The audio player is looking for a dictionary. So once again, I could actually use that schema right here as well if I wanted to. But the thing with the audio player is I actually probably really just want to pass in these arguments here, nothing else, right? So the key value thing was really just meant as a temporary holder. So realistically, I would change this to being, episode URL. And we'll go ahead and put this episode URL here. And that's going to be a string. And then our width and height, those default values in there. And I'll set the default for this one to being none. That way I still have the condition working correctly. In which case I can now use this one all around. And there we go. So now we've got no audio found. I'll let you finish that same thing with the other one. So then going back into our table, this is now a little bit better. So I can just go ahead and use just the podcast episode URL. I don't need to pass in a dictionary at all. That was just something to show you what you might do in terms of thinking through this. So this, of course, is no longer valid data because we now have this schema, which I think will make things a lot easier and a lot easier to actually store the data. So the last thing, of course, is to just verify all of it is still working. So we'll go into Reflex run, and then I'll go ahead and take a look at our search here. I'm going to just do a quick search for like maybe a Python and AI, and this will now search it. We get a validation error in here because it's looking for a string type. So we got an input type of integer. So this actually brings us back to now, this actually should be an integer. We could also say or a string. That probably would work as well. So let's try that again. And now podcast and AI, quick search here, and there we go. Same exact data coming through, but now in terms of our code, it's going to be a lot more effective in storing this data and just using it throughout all of our code, because now we have a fairly rigid schema that also has some data in here that we would end up wanting to use, which I think is pretty cool. right away, as soon as I see this schema, I'm like, okay, this is going to be the sort of validation schema. I want to also have this in as a model. So inside of my podcast here, I'm going to go ahead and do models.py, and then I'm going to go ahead and bring in that schema, basically the exact same thing, but we're going to change it with we'll import Reflex, of course. So import Reflex as Rx, and then this is going to be rx.model and table being true. And then the question here is like, what things do we want to allow to be optional or required, right? So in the case of the track ID, this is going to be one that we'll probably want to keep in here. I'll also go ahead and do from SQL model, we're going to import the field itself. And so I'm going to go ahead and use that now as a field versus the Pydantic one, mostly because this is made more for the database itself. So this doesn't need an alias anymore, but the track ID itself, perhaps we want to allow for either data type. If you wanted to allow for either data type, you totally could with a string, but I'm going to only allow integers because that's what the Apple iTunes API, I believe, only gives, which right off the bat, I want to also change the schema as well. So realistically, I might even call this my Apple Podcast Track ID. I might even change it just to keep track of the different APIs you might have, but that's outside the scope of this one because we are using the Apple one. And so the field here is an integer, that track ID. I believe all of them are required. So I'm going to go ahead and leave that as a required field itself. Now, one of the things I might do though is add this in as an index so that it actually is more efficient on the database side when we go to look it up. This also might be true with the actual track name based off of if we're going to be searching it or not. I'm not going to do that. The episode URL, I actually don't know if this is required, so I'll go ahead and say none. I would imagine it is required because it's a podcast episode. There needs to be a way to access it, but I'm going to go ahead and leave it in there as being none, and then I'll go ahead and give it a default value also as none. Okay, so it's going to be either one, otherwise it's none. Our release date, this is also one of those other ones where maybe it has it in there, maybe not. So once again, I'll go ahead and say none, and then I'll have it as an optional value also as none. Collection name, I think this one's probably required. I think all of these other ones are probably generally required, but of course they don't need any of the aliases in here at all. And so I'll go ahead and leave the collection name as, well, let's go ahead and have that as a default value being potentially none. The collection ID, I will leave that in as a default value with an index as well. And this is mostly for us looking up. This is another one where it might be an Apple collection ID. And this is like the podcast show ID. And this is like the podcast show name. The reason I think these are named collection is because these are based in actual albums, not in podcast. So it comes from iTunes like in the early 2000s, basically. And so there we go. And now we've got the URL here for the artwork. I'll also put in a default being none in here as well with an alias gone. Okay, I no longer need that configuration. This is now going to be our model schema that we want to have. Now the question really is, where do we actually want to start using this data? Now, on one hand, we could probably use it in the state when we do our API search. We could do some sort of database storage in here every time an API search is done. I actually don't want to do that. I want to do it based off of the reaction to any of our users. So like, why would we store API data? So if we come in here and we have some API data that we want to search, why would we end up storing it if there's literally nothing that the user does? So if we searched for Django and ChatGPT or some gibberish, and maybe you're like, I don't want to store this one. I don't want to store this one. This one I don't want to store either. Like, why would we store it in our database if we're never going to use it? Now, on one hand, you could think of it in terms of you want to store everything and because eventually you'll do all this data analysis on it. I totally get that. But on the other hand, from a practicality standpoint, and if you were to release this in production, if you store all of those results every single time, even if you do it efficiently, you might end up having way too much data on your hands that you're just simply not going to use. So I would rather do it based off of user interaction and storing this data then. Let's go ahead and add in a user interaction to our podcast row. So if the user were to select a few items, it will actually run some sort of interaction. So the way we do this, of course, is by creating a state. So I'm going to call this my podcast episode state, and it's going to be rx.state. And then the idea is we'll do rx.event, and this will be something like user did interact. And what we want is the podcast itself, which for now we're going to go ahead and say any, and then I'll just print out, user did interact, and then we'll go ahead and add in the podcast itself. And then I'll also try and do get maybe the title itself, which was, if we look in there, is the track name. Let's go back in here and we'll go ahead and do that. Now there's a reason I'm doing any for the moment, but let's go ahead and grab this. And then into our table here, we'll go ahead and implement this one now. So the idea then is in our table row, in the header itself, I'll go ahead and add in rx.hstack and then keep that podcast name still, but then also add in a button. So we'll go ahead and close off the hstack here, and then we'll do rx.button, and I'll just go ahead and say like, and then on click, we want to go ahead and do that podcast episode state, and then we would do user did interact, and we want to pass in the podcast equaling to the podcast. And then we'll go ahead and put a little comma here, and then the actual track name, we might want to do rx.text, just to make sure that that is pretty obvious. Great. So now we've got this interaction here, and so we've got this like button in here now. So let's go ahead and take a look at what it will print out. I click on one of these things, and there it goes, user did interact. I print it out, and it's printing that stuff out. Okay, so why did I use any versus the actual schema? I'm going to show you that right now. So we've got our podcast episode schema here. I'll come on down into my podcast, and I'll go ahead and use the schema now, in which case I should be able to do .track name and save it as is. So now when I go to interact with it, I should maybe see, well, this error. So why is this error happening? Well, the actual podcast episode schema is actually just based off of the API results. So in this case, I want to go ahead and do the raw API schema and call it something like that, whereas the actual podcast episode schema is going to be basically the same thing, but no longer needing the alias data in here. And so that's why I went ahead and did it just like this. And you can obviously set all of the defaults in here as you see fit. The idea now is this raw API schema is what we'll end up using on the search results because it's basically the same. And then we'll come down and do that. This, of course, will now transform those results into the podcast episode schema, which of course is still a little slightly different to this. So the way I would actually end up doing this then is being something along the lines of for X in API results. I'll go ahead and say valid data equals to this right here, .model validate. And then that will be our actual X data in here. That should actually validate that data for us. And then we would actually go ahead and do our final data is going to be equal to the podcast episode schema now. And then unpacking that itself, the valid data in here as model dump. And then, of course, adding this into my final results here, which we'll go ahead and say final results equals to an empty list. And then we'll go ahead and paste that one in here like that. And then our final results dot append that final data. Now, there's a way to combine these things, but I want to keep them separate for now, just because it makes it a lot easier for me to see this stuff. So that now, when I go to do this interaction and really just use this schema anywhere else, it's not going to look for the aliases at all. So now when we try to do this again, I can go ahead and hit like on any of these buttons, and now it actually shows me the proper schema data. So if we come back in here, we can say now it's podcast, and we would do something like podcast and then grabbing, let's say, the track ID, right? And so now I've got all of those types in there, as well as just really simple dot notation we can work off of for all of that data when a user does interact. So slight change to the schema. Now, one of the things to think about here is perhaps now we want to start actually moving towards the model itself instead of just the schema. But again, I only want to store this data based off of the schema. So that's something we need to do in a moment. But of course, the idea here is we have a like button. There is some interaction there. Now you could try this on click in other areas. So for instance, the release date, you could probably try it there. The collection name, probably could try it there as well. In which case you could then go ahead and select a bunch of different things, click on stuff, and see that all of that data is still coming through. So this is also another way to just track what a user is doing in general. You can have these click events with a dedicated state that will handle that sort of interaction. In our case, we're not actually tracking the number of clicks they do. You definitely could. You would need a model for it. All we're doing here is just making sure that this podcast exists in our database. So at this point, we naturally want to store this podcast information, this podcast data into our interaction. So the idea here is we're going to have something like our default values in here. So it'd be these values. This is what I'm going to end up storing. I'm going to hard code these ones. And of course, our track ID is equal to the podcast.track ID. The reason I'm hard coding these ones is to just ensure these are going to be the only fields I'll end up updating. And of course, it's going to be done with the rx.session as session. And then we would basically call our model, which of course is our podcast episode here. So we'll go ahead and bring it in with our from.models. We're going to import that one, the podcast episode. And then we'll go ahead and run some stuff here with the, let's go ahead and say update or create podcast episode. And then we'll go ahead and do that exactly inside of the podcast episode class. So this is kind of the idea. Jumping into our models, I'm actually going to have a class method on here so that the entire model logic is inside of this class itself. I might often have a services file that would do basically the same thing, but I'm going to go ahead and keep it in as a class method just to keep things a little bit simple for me. Now the model itself, I want to add a couple new fields on here as well, which is really just going to be tracking our user interactions, right? And then when the last one ended up happening. Then what we're going to do is we're going to create a class method called update or create. Now I'm going to go ahead and copy and paste this for a reason. Now the idea is you want to import these few fields here from SQL model, and then we're going to go ahead and create this update or create method here. So what we've got is we're looking for a track ID. This is going to be the base level that we will need. So back into our state here, what we would then do is we would do something like podcast episode dot update or create. Then we're going to go ahead and pass in the session first, then the track ID being equal to this track ID, right? Then the next level would be our defaults, the actual default values that we're going to be bringing in to make the either update or create element in here. And so that's what's going on with that. Then the next part of this would be the actual query itself. So this query says select class, which is going to be this class right here. So it's quite literally the same thing. Of course, in class methods, that's how it works. So you can use the entire class itself. You can label it if you want to. The reason you might want to label it is if you want to remove the class method and turn it into its own sort of module itself. And so we've got our track ID. We're doing a query where this track ID is stored in the database. Then it's going to execute that query. If this comes back as none, that just means it's not in the database yet based off of that track ID, in which case we can then go ahead and create it based off of the data that's coming in here, which would be the defaults first, keyword args second. Keyword args second, meaning that it's not actually going to, or that's going to take precedent over the defaults. So for example, if we went back into our state here and I wanted to pass in something like the track name equaling to podcast, podcast ABC or whatever gibberish, this would become the track name always, basically. That's kind of the idea there, where these defaults are kind of going to be the updating process that will come first. So this order of unpacking is how that ends up happening, whether it's create or update data. And so the create method is very simple. You create an instance, you add it to the session, and then we have this Boolean value of whether or not it was created. If it's actually an instance, if the database does find this value based off of this query, then what we get here is the ability to update it based off of the key value pairs that are in this update data. It's a very straightforward process. Then we're going to commit it, then we're going to refresh it and return back those values. So going back into our state here, then we could say something like instance and updated is going to be based off of those two things. Now, the other part about the instance itself is I want to actually have the ability to
increment the data in here, as in increment the user interaction. So this user interaction here, and also save that data. So I'll go ahead and add in another class method for that. So come in here and do class method, and then I'll go ahead and bring in this right here. This should allow for that to happen within, or rather, we actually don't want this as a class method. We want this as an instance method because we see self here. It's going to now adjust to the self. It's not the entire class, but the instance itself, in which case we now see that. And so now I'm going to go ahead and go back into my state here, and then we'll just go ahead and do instance dot increment interaction, and then we'll use that same session. So basically now, every time a user interacts with this, we will see this instance come through, which you can actually see with that print statement like that. Great. And we can also see whether or not it was updated if we want to. So we now have this increments going on. So let's go ahead and make sure that we have everything saved up. And I'll go ahead and do a reflex DB and make migrations just to make sure our database knows about these changes, and then reflex the DB and migrate. Now, of course, if you were to have run this before with the podcast episode, I just added these two fields. This is the only migration stuff that would have been changed if you did already add this database to your actual project. In my case, I didn't, so I have everything coming in there. And so now we can verify this, that it's actually creating all of these interactions. So let's go ahead and save everything, and we'll go ahead and do our reflex run, and we'll go ahead and take a look at our project here, and we'll just do a quick search here. Let's go ahead and search for, let's say, like Python AI, and search it. And then what we'll get is all of this data in here. And then I'll go ahead and change this just to simply Python. And there we go. I'm going to go ahead and like it. I get function does not support the context manager protocol. So this should be initialized. Okay, little session issue here. So let's go ahead and try that again. And we'll go ahead and say Python, search this, go ahead and select this, and then we get a numeric value out of range, integer out of range. So what this means is we are using too small of a number, or as in we're using an integer when we need a different data type on the database. So right off the bat, I'm going to go ahead and drop this track ID. So we'll go ahead and cancel out our Reflex server, Reflex DB make migrations, and then we'll go ahead and Reflex DB migrate to remove that field. Then we'll come back in here and we'll bring in the big integer field from SQL model, and then we'll go ahead and set the SQ or the SA type, as in SQL Alchemy type is going to be that big integer. Now we'll go ahead and make those migrations. We'll run our migrate, which should give us another field in here, maybe even a couple more. So let's go ahead and take a look. We see that it's now using the big integer field in here after we went ahead and dropped that field in there, which was a data type of simply integer. So with this in mind now, let's go ahead and reflex run, and then we'll go ahead and take a look at our project here. Do a quick search for Python again, hit like. This time I think it did actually interact with it. And of course I'm printing this out, and now I can see the number of interactions that are coming through, which is pretty cool. So let's go back into the state here, and I'll just go ahead and instead of instance, I'll go ahead and do the instance dot user interactions, and we'll see the count that's going on for that. And I'll put this in as an underscore because we no longer need that anymore. So let's go ahead and refresh in here. And again, we'll do our Python search. We'll get that quantum leak one. I'll press it a bunch of times, and in which case it now shows me that value. Now, obviously the downside to this, the way it currently works, is that a user could press that 1,000 times and kind of skew the results in there. So realistically, in the long run, you'd probably have another database table that actually keeps track of this specific user and their specific interaction so that it sort of toggles back and forth. We'll see generally what that might look like, but the idea here is we now have a way to add this data into our database based off of user interaction, regardless of how many times they might have liked something like that, right? And so you would end up seeing a bunch of different data in here in your database as users interact with it more, which I think in the case of an API makes a whole lot of sense. we're not going to implement a user like model so that we can actually keep track of the things a user may like or follow. So the idea here is we're going to go ahead and jump into our podcasts, and right underneath it, we're going to go ahead and build this one out. And it's going to be a podcast like, and of course it's rx.model, and then it's going to be table being true. And then we're going to put in our few items in here. The very first one would be something like our episode ID, which will be an integer field itself, and then it's going to be a foreign key, basically to, well, the podcast episode.id. Okay, and then we're going to go ahead and add in index being true. So this foreign key means that this podcast like will be associated to the podcast episode itself. Then we're also going to bring in our user ID. We've actually already seen this one before, of course, inside of our contact model. It's going to be the same as that one right there. Now, in the case of this one, we actually need the user ID to be required to actually have a like of some kind. A little bit different than the interaction that we did up here, because this is now tied to an actual user. So of course, the next thing would be maybe like a created at, which we did do inside of our contact model. So go ahead and copy that one in there, and we'll bring that in. This is mostly just to keep track of when this like happens. It doesn't necessarily have to be this way though. So I'll go ahead and import a few things related to it. We don't need the date time. I think all we needed was to bring in SQL Alchemy in here as well. And there we go. Okay, so now we've got this podcast like in here. And there's another thing that we can do, which is called table arguments, to add in something called a unique constraint across the user ID and the episode ID, just to make sure that those things are unique when we go through and create them. So the idea then is a few different class methods that we'll put in as well that will help us with this session. So same as we saw before, is we're going to do a query to look up the two arguments now, the user ID and the episode ID. Then we're going to go ahead and see if there are any existing ones. If there are, we're going to get rid of it. So this is the toggle portion of it. Then after that's done, then we'll go ahead and add in a new like based off of that value. And then finally, we'll check whether or not this user is liked as well. So those are going to be the arguments. And then we've got our tuple coming back, which is a nice thing to have as well. So this is going to be our podcast likes. So how do we actually implement this now? Of course, what we want to do then is we want to go into our podcast episode state. And now I'm going to go ahead and do something like rx.event. And then we're going to go ahead and say something like user did toggle like. And it's going to be self. And once again, it's going to be the podcast episode schema again. And so right off the bat, I need to make sure that this podcast episode exists. So it's going to be very similar to this, but I can actually improve this quite a bit. And that is, I can just say the data is podcast.model dump. And then I can actually come in here, grab that instance itself. I may or may not want to add in the user interaction here. I'm going to go ahead and say not. I also, of course, want to make sure that I'm bringing in the session value for this one, which is going to be rx session. So we'll go ahead and bring that in right there. And then, of course, the track ID is going to be based off of the data. So I can do data.get the track ID. And then the defaults can just be that data itself. I don't actually need to use the defaults either. I could just pass it in itself, but I'm going to go ahead and do that. I could also do a pop track ID if I needed to, but the actual update or create does a lot of good things in there that we don't really just need to implement at this point. So that, of course, is going to ensure that this podcast episode is created. So I can go ahead and just kind of ignore that altogether. So the next part of this really is going to be, or well, actually, we probably shouldn't ignore it. I realized why, and we'll see this in a second. Okay, so the next part is going to be our async function. So just like what we saw in our contact form state, we've got our clerk value in here. So the question then is like, oh, where are we going to put this same sort of state? Well, again, it's an rx.event, so it's another state handler. And so we're going to put it inside of here as well. So I just want to go ahead and copy that and grab our clerk user ID inside of our now podcast state. And so I'll go ahead and do that. We need to bring in reclerk now. So we'll go ahead and import our Reflex clerk as reclerk. Okay. And so basically, if the user is not there, we'll just go ahead and
skip it, basically. So if not clerk state dot user ID, then we'll just go ahead and return back the event. Otherwise, we now have the user ID itself. So we'll go ahead and come in here and we'll go ahead and give our user ID equaling to that. We could probably and probably should just put this back up here and do it something more along those lines. Okay, so now we've got our podcast episode. Now, again, we maybe return this after we put the podcast episode in. But in my case, if somebody's going to be liking a podcast, I really only want to keep track of that podcast if they're actually a user. So this user didn't interact would probably be something along those lines as well. So, of course, the next thing would be our model for it. So our podcast like model, and how we would end up going about doing that is passing in our user ID and, what do you know, our episode ID. So let's go ahead and bring that one in now to our state, and just like that. And then this time we're going to go ahead and change this to this from being instance to being the episode instance. And now we'll go ahead and do our podcast like, and we'll go ahead and do toggle like, and that's going to be the session, and then the user ID, and then the episode instance dot ID. And then whatever's coming back, which is going to be whether or not they liked it and what the instance would be, which in our case, I'll just go ahead and say is liked, and then an underscore here. I don't need the object. And then I'll just go ahead and print out the user ID, and then likes, we should say likes, true or false, and then the podcast itself, which would be the episode instance and the track name. Obviously, I could change this a little bit as far as the verb is concerned, but there we go. So now that we've got that, let's go ahead and run our database migration. So we'll do reflex db make migrations. And then if everything went correctly, then we've got this in a good spot. But of course, things did not go correctly. So why is that? Well, it has to do with this foreign key here. The way you actually write out a foreign key is not this way. You would put it in as a string like this, and then you would lowercase the actual item itself, which is basically taking the field in the actual table and the field itself. So now that we've got that, let's go ahead and try the make migrations this time. This time it ends up working. And of course, if we look in the migration itself, we should see that reference going in correctly. And so episode ID is going based off of the table.id. And there we go. And then I'll go ahead and run migrate now. And then we've got our database entry in there. And then the final step, of course, would be to actually do that toggle, which at this point is fairly straightforward. We already have our like button here. Now it's just user did toggle like, and then we can actually see what that value would end up being. And so let's go ahead and run our project now, reflex run, and then we will be able to see this like button in action. While that's spinning back up, one of the things we also might want to have in here is the actual, like value, like what is the like value itself for this user. So this is something that you may or may not want to have on here. So what I'm going to just say is we'll just go ahead and say liked, and this is going to be a Boolean value and the default being false. We won't have the current state yet. We'll just have the new state basically. So self.liked equals to is liked in here. And again, we just want to make sure that that model is returning back a true or false value by default for the toggle like. Okay. And so as soon as I have that state element in here, then let's go back into our table. And we might even have to do something called yield. We'll see that in just a moment. And I'll toggle that as well. So then the actual label itself, so the like label is going to be equal to the rx.condition, and this is going to be our podcast state, and we'll go ahead and say liked, and then whether or not it's liked, we'll go ahead and say liked, and then like. Okay, so there's a chance that this doesn't work correctly because of individual podcasts themselves. So we'll see what this does in just a moment. Let's see if our project is now running. Looks like it is. I'll search for Python here, and there we go. And then I'll hit like, and now they all say liked.
That, of course, is not what we want to have happen. We do want to change that a little bit. But what we've got here, of course, is showing me these likes coming through. So back and forth, they are actually toggling in some sense. But of course, the problem here is now it's doing the like state based off of everything, which is absolutely not what we want to have happen. So the button itself is probably going to have to change a little bit based off of that actual value. That's something we'll do very soon. But at this point, we now have a model that allows us to like individual podcasts themselves, so we can also create an entire page full of that stuff. So at this point, we have a like state that can toggle, but the actual label itself doesn't toggle, or it doesn't toggle correctly. If it was a detail view, it'd probably work fine. But what we want to do is we want to implement another state element. So down at the bottom here, I'm going to go ahead and do the podcast, or let's say user podcast like state, and this is going to be rx.state. So the idea here is we want to see what this user likes in general as well. So we're going to go ahead and do rx.event, and we're going to define an asynchronous method, and I'm going to just call this onMount, and it'll take in self, and then it's going to do a few things. The first thing that it's going to do is it's going to grab our user stuff. So I'm going to go ahead and copy all of this right here, and we'll paste it in. Notice I'm not bringing anything else, because what I'm going to do now is I'm going to do a query of some kind, which will select some data. So let's go ahead and see what this looks like by actually doing out our query. I'm going to import, we'll say from SQL model, import select here. And then I have my two models here. I've got my podcast episode and my podcast like. So the idea is I want to do a query that's going to give me my liked podcast track IDs, which of course is going to be a list of integers themselves. So when I'm saying the podcast track IDs, I do not mean the podcast episode ID, but rather this track ID value right here. So inside of that state element here, our query is going to look for exactly that. So podcast episode dot track ID. Okay, so I want to find the related track IDs for what this user likes. The way we do that is by using a join. Now the join is possible because our podcast like table, which we first off select the table, is actually corresponding or related to this podcast episode because of the foreign key right here. So this foreign key right here allows for us to do a join in this way. So we're going to go ahead and do our podcast like.episode ID, and this is going to be equal to the podcast episode.id, right? So whatever we're querying here is going to be inside of this item. And then of course the final step of this would be where.where. And this is where the foreign key really makes a big difference. We grab the podcast like.user ID is equal to the clerk user ID. And this is now going to be our query that will give us back our track IDs as a result. So we can just go ahead and do session.execute that query, and then we'll do fetch all. So the fact that I'm selecting only the track ID means that these will be only track IDs themselves, and in which case I can go ahead and say self.liked track podcasts is equal to those tracked IDs. So I'm going to go ahead and print this out so we can see that coming through, and I'm going to take out any other print statements I might have in here. So my search results, I'll go ahead and get rid of those. And then I think we still have a few more. So let's go ahead and get rid of the liked message here. I really only want to see those liked IDs in there. Feel free to bring back the print statements later if you want to. Okay. And there we go. So now we've got our track IDs here. Let's go ahead and take a look. Assuming that everything compiled in here, we are going to go ahead and bring in this state into our table. So let's go ahead and bring it into our table, not into the table row, but rather the entire table. So when the table mounts itself, that's when we want to go ahead and trigger this. And the way we do that is by using onMount here. This is another kind of event, which is why I have the method of onMount in here as well. So we might consider changing the method name to maybe handle onMount. So let's go ahead and do that so it's a little bit consistent with our other events. So go ahead and do that there. Okay, great. So now we should see those track IDs when we get a print statement in here. Okay, assuming that it was all saved. And if I refresh in here, what I see is all of those track IDs. This is great. So it's now showing me those track IDs, in which case in my table, then I can scroll back up to this table row and I can use that data. So in my like label, I can grab that data and then grab our liked track IDs. Then I can do .contains. This is basically the same idea of saying, item in some sort of list, but you use contains because it's going to be a front end element. The thing it's going to contain is the podcast dot track ID. And so now if we were to say that, if I refresh here, I should have some things being liked and some things not, right? So of course, if I were to toggle it, it should still toggle, but at this point it's not. Unless I refresh the page, then it will go ahead and toggle all of those items like that. Great. So of course I wanted to toggle when we actually run the items, when we actually select something. So the way this toggles is going to be very similar to how we were able to get our user ID. So we're going to use this get state method here when we go to toggle it. So after it's all said and done, assuming that it's liked, or even not assuming that it's liked, we just want to update the state. So this is going to be our user liked state, which is basically this right here. So user liked, we could even say user liked podcast state equals to await self.get state of that value. And then in here, I can call that method down here. So I can go ahead and just say await from that and then handle on mount. And then this will sort of refresh a local state or another state element. Okay, so let's go ahead and save that. Now I'm going to go ahead and make sure that everything's running here. I'm going to like this. Now it refreshes that state and now I can toggle it. This is of course being refreshed not just in the front end, but actually in our stored data as well. And so that's how we're going to go about doing the mounting in there for this various data. So now we have a functioning like button altogether. Now, this process is something that you might forget. I certainly forgot, so it took me a little bit of time to remember that I wanted to use my state elements in a specific way. And now I can probably get rid of this like element in here. I probably don't need that any longer. But it's important to remember a couple of things. When it came to my user podcast light state, right now I've got a lot of likes in there. So perhaps you'll have all of those likes, perhaps you won't. Perhaps you'll handle this mount based off of the query as well. So you could probably do some sort of querying. In other words, this is not necessarily going to be the most efficient way to get these track IDs because at some point you might have thousands of them, and in which case this is probably not that ideal. So the like button itself would be much better served if we had a detail view, which of course we don't have at this point. That is something that I'm going to leave out at this time. But of course, my full stack Python course that I mentioned before does go into those detail views. I really just wanted these like buttons mostly so that I can do various things with it. So I noticed that liked is still not, it looks like it gave me an error on that one. So let's go ahead and see why the stereo liked is not defined. Let's go ahead and update this again. It shouldn't be in there anymore. So I shouldn't have any reason to have the liked in here. Oh yeah, I think it has to do with our Boolean right here. Yeah, so I did call it in there and now I don't actually need to call it. I just need to toggle it. Okay, so now I refresh in here again. We'll do a quick search for Python and then I'll unlike things as I see fit. And granted, you could always change the color of those buttons as well. So say for instance, we wanted to use the button in here just slightly different. The way I would go about doing this would be actually changing this to being our like button, and in which case I'll come down here, and then this will be rx.button liked, and we can still have that on click in there. So both of them could basically work. Let's just verify this because this might cause errors as well, but we do want to see it in action. So let's go ahead and grab that one, and we'll put it right underneath after that comma. And then we'll go ahead and change this to like.
And then the variant here is going to be like outline. Okay, so let's see if that ends up changing everything for us. We don't need this like label any longer, just the like button itself. And let's see how we do. And there we go. So if I hit like, there we go. That looks a lot better in terms of that. So of course we can unlike it and all of the database entries should work based off of all of that. Great. So we now have our like button implemented both in the database side and also in the front end. We want to build out our favorites page. The way we're going to do this is by updating a states module inside of a new favorites module, which of course these are all empty pages. Feel free to add them in on your own at this point. So I'm actually going to go into podcasts, into state. I'm going to copy this entire thing. Do note that I actually changed the imports here, so you're going to want to do that as well to make sure that they're not relative imports any longer. Then you're going to go ahead and paste this state in here. And the only ones we're going to focus on here are going to be related to our user favorites. So the user podcast like state, I'm going to keep. I'm going to leave it in here. Then I'm going to go ahead and update my other one and quite literally get rid of that one at this point. The reason being is I want this particular state to be in one place and one place only, not kind of duplicated in multiple places, which means that I need to update this one as well. So we'll do from podcasts discovery.favorites.state. We're going to import that user podcast like state in there. Okay, so the reason I'm doing this, of course, is so that I can actually have a expansion on this user like state and have it just slightly different. So I'm going to go ahead and paste another version of it. This one is now going to just be our favorites state. And in this case, it's going to be, we'll have something in here called just simply episodes. And it's not going to be a list of integers, but now it's going to be a list of actual episode instances if they're available. So then our handle on mount going to be the same. Our select query is just different. We now want the entire episode, in which case we would then come in here and do self.episodes equals to session.execute of that query and then .fetch all. Now we could implement pagination, all sorts of efficiencies down the line, but the idea is I want my favorites state in here for my eventual favorites page. And the user podcast like state makes sense as well. Like I said before, this could be inside of the other state still, but the reason I'm doing it here has to do with the fact that this is now all of my favorites. It's basically the state items for my individual likes and then also all of my other favorites. So this might have broken some more things. So let's go ahead and do Reflex run and just see if any imports are broken, if my likes and searches, all of that still ends up working. So I'm going to do a quick search for that and we'll do Python in here, do a search, go ahead and see if your like state is in there working. It might not be. So it looks like mine is there. It says it, but it's not really showing me anything. So maybe we've got an issue with our saved elements in here. And we should see our form. If we needed that like state in our form, doesn't seem like we do. We don't need it in our schemas or our models. So everything should be back to where it was. And now I should be able to refresh. And there's the things back. Okay, great. So we've got our user podcast like state is not defined. So let's go ahead and do a quick search here as to why it's defined there. And there it is. In the state, it's not defined. Okay, so that makes sense. So we'll do from podcast discovery.favorites.state import that user like state. Okay, so now it should actually work fully. So we're going to like it. There we go. So we're back to where we were. Not that big of a deal. But the change here is going to be, of course, our favorite state. So at this point, I'm going to go back into my podcast, grab the same table, and bring it in here. A lot of this is going to work very similar to what we saw before. So now, once again, I need to bring in the absolute imports here. So we'll go ahead and do from podcast discovery.podcasts. We'll bring in these elements in here. So the question here now is, how do we actually grab our data? Well, it's going to be our favorites state now, no longer an API request. So now when we go into our search results table here, the on mount is going to be
the favorites state on mount because that's how we're going to render out everything. So we probably don't need our conditional stuff in here. All I really need is going to be our results here. So the rows themselves, I'm going to call this, instead of search results, I'll call this favorite rows. And that's it. Then I'll go ahead and scroll on up to the rows themselves. We'll look at that in a moment, but there's our favorite rows. This is going to be our favorites table as well. So just a slight change there. The header is all the same. This might be a good time to make these headers a little bit different or their own sort of Reflex component, but we'll leave them in as is. So the next thing is going to be our rows here. What is going to be our label? Well, it's certainly not going to be this. It's going to be basically the condition on whether or not we actually have any favorites results. So inside of our favorite state here, the condition now is going to be favorites, and we'll go ahead and look for our episodes. Now, in this case, I might want to just put in a count. So let's go ahead and do that within here. I'll go and do count int and say 0, and basically come back into my table now and say count. If the count is equal to 0, no episodes are favorited. No episodes are favorites. All right. And so that's just simply the label. Otherwise, we'll go ahead and do favorites. Let's see if that ends up rendering out the way we might want. Next up, of course, is going to be our condition here. Once again, the counts in here would be if it's not equal to 0, or rather if it's greater than 0, then we'll go ahead and loop through all of the episodes in there. Now, in this case, I probably don't actually need this condition unless, of course, I want this specific label, which quite literally means that this query label doesn't actually make sense anymore. It should just be in here, and we'll go ahead and say no episodes are favorited or liked. I'll go ahead and say liked because that's the name of the button. Okay, now we'll get rid of that query label. That makes a whole lot more sense. We now say if there are favorites, we'll go ahead and go through this process. And then the next one is the actual process itself is going to be the podcast table row. Here comes in the question, do we render out this one or do we render out the other one? Now, in this case, what we've got is the podcast episode schema. It's different than our actual podcast episode. So the change that I made actually doesn't make sense here. So this actually should be our podcast search results table row, and we'll go ahead and rename that as that. So I could do another one in terms of the episode table itself. So if I come back up here, now I want to go ahead and say the episode, podcast episode table row, and in which case we would use the model itself. So we'll go ahead and do from podcast discovery dot podcasts dot models, import the podcast episode. Let's just double check that that's the name of it that we have in here. And sure enough, there it is. And we'll go back into that one. And again, it's still in podcast because we probably want to reuse this. Okay, so that's going to be now just simply our podcast. And I think everything else will probably end up working just fine. So if we double check in this state element, or rather the model element, that all of those same fields are related to the schema, which is one of those things where you're going to want to make sure that they are related. So the real question here is, could we actually use either or, as in either data type? And I actually think we should be able to. So let's go ahead and try that out with either data type for the moment and see if that works in our actual podcast table, which of course now we want to bring that one in. So we'll go ahead and do from podcast discovery dot podcasts and then dot table. We're going to import that podcast search result table, and I'll get rid of potentially the state. We'll see if we need it, but we'll go ahead and get rid of this podcast table row here and use this right there. So as soon as I actually grab that table row, I noticed that a bunch of other things went away. And so now I've got pretty much just this. Okay, so if we did things correctly, we will see this favorites row coming out really, really soon. So let's go ahead and see this in our page now. So all I'm going to do is go into my about page. I'll copy all of the things from my about page, paste this in here, and now I'll go ahead and do my favorites page, and the actual item itself is going to be from our podcast discovery dot favorites dot table, import our favorites table here, and let's go ahead and see if we can render that out. If we did everything correctly, we will see this table out and it will have all of the rows in there. And then it will, of course, allow for that same sort of interaction in there. And of course, I want to name this favorite page, or rather favorites page, and then call this one simply favorites. And then I also want to bring this in, an import for it in my podcast discovery, the root there. So I'll go ahead and do that now and just add in dot favorites dot page, import everything, or we can import the page directly. But hopefully now we see that we've got this and we can't import the favorite state. So let's make sure I saved everything in there in all of those pages. Great. So now let's go ahead and jump into our favorites page. Let's see if it's there. And if everything's done correctly, we will see our favorites, and I got no episodes are liked. Okay, so why is this? Well, I did this count method here. What I didn't do was actually count the number of episodes that came back. So self.count equals to the length of self.episodes. As soon as I do that, the Boolean should hopefully come in, and there we go. We now have these values. If I am going to like something, notice it doesn't go away right away, but of course, if I refresh the page, it should go away, right? Which I actually like, because if I accidentally toggle it, I want to keep it there so then I can actually bring it back right away. And so this is, of course, a rapid fire way to implement a lot of the things that we've been doing up until this point. But the key of it at all would be to have some sort of reusable table. And so we just proved the reusable row does work in there based off of those different data types. It should work in both places. So let's go ahead and take a look in our dashboard again, or our homepage rather, and do a quick search for Python. Go ahead and search it up. And of course, this is actually still the same Python. I'm gonna go ahead and hit like, go in back into our favorites page, which I need to add into the Navbar, but there it is. So it's actually showing me all this. And of course, if I were to unlike everything, I would be able to see how all of this is coming in. So let's go back again, and we'll just go ahead and like one of them, and then I'll go back into my favorites again. And now we see only one's in there. Great. So all of this is working correctly. Let's go back into our favorites, and it's also refreshing when that page ends up mounting, which is exactly what I was hoping for in terms of rendering out this content and seeing it really in action on this composable, like removable sort of elements that you can use rapidly. And now we've got that consistent look that I mentioned before, as well as consistent functionality and storing this stuff in our database with our users is pretty great. If you were to reboot your Reflex application and then go into your favorites page, which of course I did add off the video to the sidebar, but the idea is you don't see your favorites being liked, like it doesn't even show it. Now, the reason for this has to do with our state, a value we kind of overlooked. So if you go back into our table as to where we got all the favorites themselves, we did this handle on mount, but what we didn't do was anything related to what individual likes were done. So we're gonna go ahead and now bring that in to our favorites mounting as well. So inside of here, I'll go ahead and grab it with our user like state, and we'll do a wait and and get state of that value, and then user like state, and then dot, handle on mount there. And then of course we want to await it as well. And now, of course, if we were to go back in, we should verify that the like button is functioning as expected. And if we were to go back, we would see that the like button is now functioning as expected. So you could always toggle in here. Now, the functionality still would have worked before, but now it actually displays correctly. So the next step here would be to actually reorder the actual episodes here based off of when we like them. Because of course, if you go back into the state for the model itself, you can see created at is in there. So what we're going to do is we're going to import another SQL model function called func. This will allow us to do something pretty cool within this query. So after this query, after the where, what we can do is we can add something called group by, and this will take in the podcast episode.id. This will group everything by that. And then we are going to go ahead and do order by. And then we'll go ahead and use that function. So func and then .max. And then we grab the podcast like and then do .created at. And then we do ascending. Okay, so let's go ahead and save that. And then we'll look back in here. What we should see is the most recent one first. So let's go ahead and take a look at this in our actual search. I'll go ahead and search for something like a, I don't know, podcast. I don't know. It's probably a bad one to search for. Let's go ahead and search for Apple. And let's see if we get anything there. I'm not getting any search results there now. So going back into Python, not quite sure why there wasn't search results for the other one, but I'll go ahead and do this snake and storages one, and then we'll go into our favorites here, and there it is up in front. But it looks like I had another one, so let's go ahead and get rid of all these. I basically just want to see if Quantum Leap's going to be at the bottom or the top at this point. So let's go ahead and do another search. I'll search for Apple like that, and maybe that one works. No, I'm surprised. Okay, so let's go ahead and search for Ruby, like Ruby on Rails. Ruby on Rails. The search API is okay, I guess. Okay, there we go. So there's a Ruby on Rails one. I'll go ahead and like that one, and then like this one. Now, the reason it takes a little bit of time is because it's actually adding it to the database and then liking it, so it does take a little time to do that. Let's go back into our favorites, and now we see that these are at the bottom, so they're not in the right order. So let's change this to descending then, and let's see if that flips this over to the order we were looking for, and there we go. So now it's actually giving us that order, which is pretty nice. Now again, this is still the podcast episode items themselves. It's not the actual like instance itself in there at all. So really the next thing, the final thing I want to do is something very similar to this favorite state, but do something like a discovery state. So let's take a look. Let's go ahead and create our discovery module. So we'll go into our podcast discovery here, and I'll copy favorites and put in discovery, and we'll go ahead and do that right now. There we go. So inside of here, I want to do a quick, replace. So find in folder, I'll look for favorites, and we will change this to discovery so we can go each one. So let's go ahead and take a look at this one. All of these I want to change. So I'll go ahead and do that. And then into my favorites here, we'll go ahead and only do capitalized ones. And then we'll come back and work this thing out. Just a quick way to get it done. Okay, so in state.py, I want this to be my discovery state. I do not want to have the user podcast like state done all over again. So I'm going to go ahead and get rid of that one, but I will need it still. So from podcast discovery dot favorites dot state, we'll import our user podcast light state. And we still might need some of these things in here. Our table, we changed all the table names in here, and the favorite state is no longer valid. So we want to bring in our discovery state. So we'll go ahead and add these items in here as well. So no episodes, maybe to show, something like that. And then we will have that same handle submit. Okay, so back into our state. What is it that we want to do here? Now, first and foremost, I'll say in the long run, you'll probably want to have a better method for handling all your different queries. Right now, we have all the queries just in the state, but I would probably have more of a centralized location to the various queries you might be creating so that it's a lot easier to manage, modify, and update whenever you need to. So the idea here is we don't need our user ID. I can still refresh the user state, which is fine, but the clerk state, I don't need to worry about that at this point. So I can completely get rid of those altogether because the actual request that I'm doing does not need to be based off of the user any longer. It can still be grouped in this way, as in like the most recent one could still be first, like the most recent liked one could still be first. But what I want to do is I actually want to order it by random. So I'll just go ahead and come in here and order it by random. I also want to add in a limit in here, as in like 20 items. So basically the most recent 20 items that we could also have as a state variable in here and just reference it like that. That's totally fine as well. Now there might be another thing that you would want to have in here is liked items that are greater than 1 or 5 or 10 or whatever number as your items start to grow. So what you would end up doing here is put in a having block, and this would be function.count, and then you would count the podcast like.id, and you'd want that greater than some number. This, of course, would then limit this query result. Now, what I would say is about a discovery page in particular is you might want to be a little bit more deliberate than just doing some random query. That's going to be completely up to you. Like if you think about something like Apple Podcasts or Spotify's podcast, they're going to be a little bit more deliberate on how they do this discovery. They might use machine learning, they might use AI, they might just have people actually pick out which ones that should be listed here. This is just an example of a more robust query that you might want to use. And so once we actually have this, I want to bring it into the project itself. So I'll go ahead and copy this one right here. And this is going to be discovery and discovery.page. We're going to import all. This should handle all of that. Let's go ahead and make sure that our page does say discovery. Looks like it does. We should be fine. And here, in terms of that rendering, I'll go into my sidebar and I'll go right above favorites. I'll go ahead and add in discovery there as well. And discovery, there we go. And this is going to be a telescope icon. And you can always look those up on Reflex documentation. And you can always look up those icons on Reflex documentation. Okay, so let's go ahead and run this, Reflex run. While it's starting to boot up, I'm also going to go into my Navbar here and maybe add in something on my desktop one where it is discovery. So we'll go ahead and do something like discover and let's call it discover and then put discovery as the link, which might be discover too. There we go. And maybe we want to give that same link to our sidebar instead of discovery, discover. Okay, so now that we've got that, let's go ahead and take a look in our discovery link here. There's some of those items. We've got discover in here, and this is of course where we're at. At this point, I should be able to refresh in here and see my user data, and then there we go. So this might be a good place where the like button, maybe we want to make sure that Clerk is fully loaded. So we would come back into our location where we had it, which was in podcasts, and then into our table, into the row here. We might want to have some Clerk stuff related to the like button on whether or not it even gets rendered if the user is not fully there. In other words, if I go into an incognito window, I may see that button still and I may try to like it. It just doesn't do anything. But it does at least allow me to see some of these items and even play them and do it as I see fit. I can also do a search for things like Django. And of course, if I go to try and like them, it's not necessarily going to like them. It's not going to store them in my database, even if I am doing these interactions for the like button. But of course, that also depends back onto our favorites and the state values themselves. We have the, we had the other one. In this case, it just is handle on mount. Maybe it's still in the other podcast schemas. We had that search state, episode state, toggle did like, and here it looks like I actually do still create them on that one and also on the interact one. So there's a couple of different places as to where I might still have them. So if I do click on some of these, they still might go in the database, which is totally fine because we're still actually interacting with it. But we now have our full-on application built out in terms of our podcast discovery. I think it's pretty great. It has some more work that we would need to do, of course, like making sure our links all work correctly and I'm able to navigate around it inside of the project itself and see all of the different items that might be inside of this project. We should now look at code as ephemeral, as in something we can delete and bring back up with no issues. This is thanks to large language models, of course, that will help us write out our code. But really what it does is it now focuses on how do we actually best serve our users? How can we do that faster and better? And I think tools like Reflex and Clerk really help level this up a lot. Clerk, of course, takes out all of the guesswork in our user management. It does it in a very robust way, which is why I partnered with them. Thanks, Clerk, for doing this. But the idea here is Clerk itself really takes away the pain point of managing our users so we can get back to building out code and projects for them, and we can manage it for them. We can take that cognitive load for them and deliver them something great. So if you haven't already, definitely take a look at the Clerk dashboard. There's a lot more stuff that you can do with your users that I didn't go over, but feel free to look at that. And of course, subscriptions and billing are definitely on the horizon for Clerk, so I'm excited to see that being integrated as well. Now, Reflex itself does a whole lot of things and is continuously building. Be sure to reach out to their team directly for things you might want to see. Me personally, I want to see a one-to-one native integration with Clerk and Reflex. I really think what Tim Child did here was really great. And it's really powerful. It's a really great start. But what we want to do is see it go up even more so that this is a one-to-one symbiotic relationship in the near future to really unlock what us Python developers can really do in a lot of places. Now, I will say these iTunes Search API is a little tricky. There's things that you might want to change from here. The point of this project was not really to master this Search API, but really just to build out something that we can start delivering value to our customers in the very near future. The other part about this is what you're going to probably want to learn a lot more of is SQL model, so you can build out all sorts of more robust requests based off of everything we've done. And of course, we can do this for our users and the data or the actual value we're trying to bring to them. So thanks again for watching. Hopefully you got a lot out of this. My name is Justin Mitchell. I really enjoyed showing you this one, and I can't wait to show you more. Let me know what it is that you want to see in the comments below, or shoot me a message on X. Either way, thanks again. Look forward to seeing you next time.